Hi everyone. Can you see me? Can you hear me? Give me a good to go very quickly and we're going to dive into the discussion of AOD. Am I visible? Am I audible to each one of you? Yes or no? Can you see me? Can you hear me? I want a good to go from all of you. All right. I guess we are live. I guess you can see me. You can hear me. Everyone. Visible, audible, perfect. Audio, video, no glitch. See, today's chapter is AOD, which is application of derivative. You already know out of the handful of highest weightage chapters that we have, calculus acquires one of the highest share. You won't believe 8 to 9 questions are asked from just calculus, out of which around 2 to 3 questions come from AOD. Oh yes, people, let me quickly tell you what I'm saying is that your calculus, when I say calculus, this actually constitutes the weightage of 8 to 9 questions in the paper, in the math paper, 8 to 9 questions, not a joke. When I talk about AOD, you can safely expect around 2 questions from here. But AOD involves concepts which get intermingled with the questions of other chapters as well. That's what makes AOD supremely important. Be it increasing, decreasing, be it maxima, minima, be it making graphs and then establishing comments and analysis about functions. These 3 things are supremely important in AOD. Supremely important. What did I say? When it comes to AOD, we have increasing, decreasing functions. That's the number 1 thing which is absolutely non-negotiably important. Number 2 is your maxima, minima. And number 3 is nothing but your graphs. So these 3 subtopics which fall inside AOD happen to be supremely important. Like they acquire highest share, lion's share in the paper. Lion's share. Yes, there is tangent and normal, questions based upon tangent, normal. Yes, there are questions based upon rate measure. But those questions actually are not that important as much as your increasing, decreasing, max, min and graphs. And that is why our primary focus today in this entire one shot is going to be to make you a master of these 3 subtopics. Of course, I'll be discussing the questions of tangent, normal. Of course, I'll be discussing the questions of rate measure. But these 3 subtopics have to be on your fingertips. You have to be a master of these 3 subtopics by the end of today's class. That is my promise. I just want you people to stay throughout the class from start to end. I will be sharing with you plethora of questions, huge variety, beautiful variety, relevant question bank is going to come from my side to you. The only request is stay attentive, sit with your pens and notebooks. Whatever questions I share with you, you have to obviously solve them, but in between, whatever concept or result or formula or trick or shortcut is coming into action, please write it down separately, make a dabba, make a box around it. I am not claiming questions to be repeated as it is, Control C, Control V. No. It is happening, it has happened, but that's not what I want you to rely on. But I definitely want you to rely on one thing which I always say, and that's a guarantee. Concepts will repeat, bache. Concepts will repeat, results will repeat, idea will repeat, approach will repeat, a particular variety of question will repeat. Digits might not, exact framing might not, but of course, the soul of the question repeats. And that is why I'm asking you to write the concept or result or any formula, any idea involved in the question separately as well, so that towards the end, when you revise all the questions, you're skimming through the pages, you're going through all the questions, towards the end while revising, then those right-hand side dabbas actually sit in your head in the photographic memory. And that is what actually pays you back in the paper. So this little bit extra hard work today will pay you in the paper, for sure. 100% tried and tested technique coming from a topper, who has been a topper from, I don't know, 6th grade, 7th grade. It's been so many years. So these are here and there. I throw some strategies which I myself have applied and have gained tremendously from it. Alrighty. Shall I go? Give me a quick good to go. Hi Santosh. Hello Naresh. People, quickly share the session with all your friends, all your classmates, your fellow mates, Everyone, this is a guaranteed 4 to 8 mark in your pocket session. AOD cannot afford to miss. AOD cannot afford to take it lightly. AOD, supremely important. And I will make you a master of this chapter today. So share the session, share the link of this class with as many folks as you can. Invite them here on the Rankplus JEE English channel very quickly. The session has started. It's going to go on for pretty long. And I want you all to please sit with a cup of water, a glass of water, and something to munch by the side of you, because this is going to be a long session. And also, let me tell you, this is going to be a super fun session. When you start seeing mathematics, when you start visualizing mathematics, when graphs come into play, that is when actually all us mathematicians get a big smile on our faces. And this chapter makes math a magic, because this chapter makes us see math, makes us feel math, makes us visualize math, makes us play with math. That's something which not all chapters are capable of. And that is what makes this chapter super fun. You won't even realize when the time will pass. You won't realize in this span, plethora of questions we have already solved. You won't even realize the time is going to go so smoothly. So, hello Pragna. Differentiation, yes, this is AOD, this is application of derivative. So when you say differentiation, logarithmic differentiation or implicit explicit differentiation, of course these subtopics under core differentiation acquire a good weightage in the paper, but on top of that is AOD, guys. AOD is a weak point for many students, and if that is something which is the case with you as well, this is your chance. This is your chance to lock it. This is your chance to ace it. This is your chance to excel at it. So without any further delay, let me start, everybody. Let me quickly start. AOD, which is application of derivative. The very first word which you have to be comfortable with is monotonicity. Monotonicity or monotonic function. Now, in general in life, we have said it a lot of times, life has become very monotonic. Oh my God, this is such a monotone color, such a monotone color combination, such a monotone outfit, such a monotonic routine. What does that mean? What does that mean? What does that mean? It simply means it's the same. When I say my routine has become very monotonic, it's so boring, that means there is nothing new, nothing exciting, there's no change, it's just fixed as it is, same. Same is what monotone means even in regular language. That's what has inspired math to take the word monotonic function. When you say monotonic function, there are two aspects in which we use this. One, where the function is just increasing, the behavior is throughout the same, it's the increasing behavior, or decreasing behavior throughout its domain or throughout the interval, wherever we are testing. When I say it's monotonically increasing, that means it's throughout increasing. It's the same as the word suggests. When I say monotonically decreasing, it means it's throughout the interval or throughout its domain decreasing. The behavior is the same. So that's what monotone means. Now, let's understand quickly. Listen to me carefully. When I say monotonically increasing, it can either increase like this, or it can increase like this, or it can also increase like this. Now, the first case, please catch hold of the first case, guys. This is concave up. How many of you all can recognize? The shape is concave up, which is a smiley face. When I say a smiley face, you know how smile looks like? How do we draw a smile? So the smile is what represents concave up. And when you say a sad face, that means concave down. So this is concave down and this is concave up. So when I say your monotonically increasing function can actually behave in three formats, it means it can either be throughout increasing and concave up, or it can be throughout increasing and concave down. This is concave down and throughout increasing, or it can be neither concave up nor concave down, like a straight line. Even this is increasing. Did you understand? Did you understand? Now, one thing before I get on to the condition, the mathematical condition, please make sure to see this. Don't cram it. Don't ratify it. Just see this. At any point on this graph, when I draw a tangent, the angle that it makes with the positive direction of x-axis is acute. Can you see this? Can you see this? At any point on this graph, when I make a tangent, the angle it makes with the positive direction of x-axis is acute. And here, though this is a straight line, you can clearly see the angle again is acute. When the angle of inclination of the tangent is acute, that means slope is positive. How many of y'all know this? How many of y'all know this? Santosh, don't worry about the remaining class. I will be taking another live where I will discuss the left out part. So because of some technical glitch that actually got removed, I will be taking another class where I'll complete the remaining part of binomial. Don't worry about it. It's been taken care of. Very soon you'll see on the channel the session being scheduled as well. So please don't worry about it. Right now, let's focus on AOD. So as I said, when angle of inclination of the tangent is acute, it simply means that the slope is positive. Yes or no? Because when theta is acute, you will say tan theta is positive. Here also tan theta is positive. Here also tan theta is positive. And what is tan theta? The slope. This is slope. And you know, first derivative represents slope, isn't it? D by dx of the curve at the respective point represents slope of the tangent to the curve at that point. Yes or no? Suppose this point is P where I have drawn the tangent, then d by dx of this curve, whatever the curve is, at the point P. At the point P is what is representing the slope, and this is positive. This means your f dash is positive at point P. Yes or no? Similarly in this case as well. And that is why, this is where the condition comes from, and that's why I said do not cram it. I am never in support of cramming anything. Try to see, try to feel, try to visualize, and automatically you'll reach to the mathematical condition. Guys, this is so pretty. This is just so beautiful. Whenever your graph is increasing, or rather in this case, strictly increasing, your derivative will come out to be positive. That means the slope of tangent at any point on the curve, on a strictly increasing curve, will always be strictly positive. When do I say a graph is strictly increasing? Why did I add strictly word? Anybody, any clue? Naresh, anybody, any clue? Pragna, Santosh, any clue? When you say strictly increasing, what do you mean? See, look here. When you say a graph is strictly increasing, what does this mean? This simply means, let's say this is x1, one of the inputs, this is x2, one of the other inputs, then this is your f of x1 and this is your f of x2. You can clearly see, because the graph is strictly increasing, as the name suggests, you increase the input, output will increase. You increase the input, output will increase. You decrease the input, output will decrease. You decrease the input, output will decrease. That means if x1 is less than x2, f of x1 is strictly less than f of x2. This is what this means, guys. This is what this means. Are you able to understand? This is when I say the graph is strictly increasing. It's just keeping on increasing. Whatever is the value before, other one is greater than that. Next is even greater than that. Next is even greater than that. Next is even greater than that. So as you are increasing the input, the output correspondingly is also strictly increasing. Okay, so this is how a strictly increasing function looks like. Condition is derivative has to be strictly positive, and an equivalent mathematical definition says whatever is the relationship between input, same exact photocopy is the relationship between output. If x1 is less than x2, f of x1 will be less than f of x2. Or I can say if x1 is greater than x2, then f of x1 will be greater than f of x2. Both these are actually the same. Both these are actually the same. Both these are actually the same. You decrease the input, output will decrease. You increase the input, output will increase. That means the graph is behaving in a strictly increasing manner. But it can be concave up or concave down or nothing. Remember that. When you say concave up or concave down, what are the conditions? Just remember it in mind. I will be coming again on this topic. F double dash is positive means the graph is concave up. F double dash is negative means the graph is concave down. Just remember these conditions. Okay, remember these conditions. So first derivative tells about the slope. Second derivative tells about the concavity. Okay, got it? Yes ma'am, no ma'am? Hi Srinivas, yes? Now I'll tell you about increasing. Look here. A function is said to be increasing when it's actually, I don't like the word increasing, when it's actually non-decreasing. Ma'am, what does this mean? What does this mean? Look at the graph. Look at the graph, guys. Look at the graph. Look at the graph. I am saying this is an increasing function. Rather, a better word would be non-decreasing. See what's happening. What's happening in the graph? It's increasing, increasing, then becoming constant, then increasing, increasing, increasing. Yes or no? That means throughout the domain, wherever we are checking the monotonicity of the function, throughout the domain, there is a relevant, significant part where the function is not decreasing, but it's also not increasing. It's not decreasing, yeah, but it's also not increasing. It's becoming constant parallel to x-axis. At that portion, which is a significant interval in the domain, when you draw the tangent, it will be parallel to the x-axis. So before this part, when you draw the tangent, slope is positive. After this part, when you draw the tangent, slope is positive. But at this part, when you draw the tangent, it will be parallel to the x-axis. That means derivative will be 0. So either the derivative is positive when the function is increasing, or for a significant interval, it's becoming flat, or rather it's becoming parallel to x-axis where the derivative is 0. Then again, it's increasing, so derivative is positive. Maybe then again, it becomes flat for some time, derivative is 0, then derivative positive, then derivative 0, then derivative positive, and so on. So this graph definitely is nowhere decreasing. No. But it's also not everywhere actually increasing. It's increasing, becoming flat, increasing, becoming flat, increasing, becoming flat, and so on. That means there is a relevant, significant interval in the domain, not just 1 or 2 values. There is a significant section in the domain where the graph is becoming parallel to x-axis. Okay, so this is either increasing or becoming parallel to x-axis, but it's not decreasing. So a better way to put such a function is that it's a non-decreasing function where the derivative can be positive or even 0. It is allowed the derivative of this function is 0 as well, and that is why, what do we say? F is increasing if and only if f dash is greater than or equal to 0. F is strictly increasing when f dash is positive, but f is increasing when f dash is either positive or 0. Either positive or 0. Similarly, you can clearly check here, bache. Look at this x1, look at this x2. x1 is less than x2. Between x1 x2 graph is increasing. So you are getting x1 less than x2. F of x1 is less than f of x2. But you go a little ahead. Now look at x2 and x3. x2 is yes less than x3, but f of x2 is equal to f of x3. So in strictly increasing function, what was happening? You increase the input, output increases strictly. But here, you increase the input, output might not increase. It might increase or might remain the same. It might increase or might remain the same. That is why the mathematical condition for increasing function happens to be, see this one. I'll remove this one. x1 less than x2 implies f of x1 less than equal to f of x2, or equivalently you can say x1 greater than x2 implies f of x1 greater than equal to f of x2. Is this understood? Is this understood? Is this understood, guys? Is it completely understood? Yes? Got it? So f dash positive means strictly increasing, and f dash non-negative means increasing or non-decreasing. Increasing or non-decreasing. That's what's written in strictly increasing as well. So increasing and strictly increasing, I hope is clear. Exactly in the same manner we studied decreasing functions. Exactly in the same manner. See, exactly in the same manner. Decreasing, decreasing, decreasing. So this is concave up and decreasing. This is concave down and decreasing. And this is neither concave up nor concave down, the straight line. The straight line is neither concave up nor concave down. At any point you can see, at any point, bache, just try to see. At any point, if you draw the tangent, the angle will be obtuse. In any diagram, in any of these 3 diagrams, you pick up any point on the curve, you draw the tangent, the angle made by the tangent with the positive x-axis will be obtuse angle. which means your tan theta is negative. Tan theta means slope is negative. So that means your f dash is negative, strictly negative. At any point x comma y of the curve, when you draw the tangent, the slope of the tangent is negative, which means the graph is throughout strictly decreasing. And when you say decreasing, again, another thing which you can very easily notice, let's say this is x1, this is x2, then clearly check this is f of x1 and this is f of x2. Yes or no? This is f of x1 and this is your f of x2. Yes or no? Checked. That means when x1 is less than x2, f of x1 is greater than f of x2. The inequality between input and output has reversed. Both are strict, but they have reversed. This is the mathematical condition for a strictly decreasing function. Did you understand? And similarly, we have a decreasing function which more properly I should call it as a non-increasing function. I should call it as a non-increasing function because this function either strictly decreases or becomes constant for a significant period of time and then again starts decreasing. But it's nowhere increasing. It's decreasing, becoming constant, again decreasing, then becoming constant, but it's nowhere increasing. So for a significant period of time, for a proper interval or a section, it is flat or it's parallel to x-axis. That means the derivative is either negative or 0. And hence I say that derivative is less than or equal to 0 means it's a decreasing function. And derivative is strictly less than 0 means it's a strictly decreasing function. Decreasing, or you can say non-increasing. Is this clear? And again, the mathematical condition, it's very, very obvious for you to understand that it says x1 less than x2 implies f of x1 is greater than or equal to f of x2. Very, very simple. Because see, x1 is less than x2, but f of x1 and f of x2 are equal. Or it might happen x1 less than x2, f of x1 greater than f of x2 because the graph is decreasing. So either the graph will decrease or it will be parallel to x-axis, like a constant. Got it? Got it? So whenever we are studying, see, look here, this is what is the comparison. Whenever we are studying, we have 4 types of monotonic behaviors, bache. Increasing, strictly increasing, decreasing, strictly decreasing. Now, when I say increasing, a better way to say is non-decreasing. F dash, non-negative. Strictly increasing, what is that? F dash positive. Then decreasing, or rather non-increasing. F dash less than or equal to 0. Strictly decreasing, F dash strictly negative. Is this clear? And the mathematical condition between input and output, is that clear? Is that clear? Is everything hashtag HDCC till here, everybody? I want you all to tell me, is this part completely clear? Has to be clear. It's very important because increasing, decreasing happens to acquire a massive share in the paper, guys, from AOD. It's not a joke. It's just not a joke. Let's come to just 2 more definitions and then we will be jumping onto the questions. I will be throwing questions at you like anything. Stationary points and critical points. Wherever the derivative is 0, we call those points as stationary points. Wherever the derivative is 0 or undefined, it does not exist or it is not defined, it doesn't come out to be a real well-defined quantity, we call all those points to be critical points. So all stationary points are critical points, but all critical points need not be stationary points. Got it? Got it? Yes or no? Yes or no? Suppose I say my f dash x is equals to x minus 1 upon x minus 2. Suppose my f dash is this. Suppose my f dash is this. What will you say is your critical point? What will you say is your stationary point? Anybody? Which point do you think is the critical point? Which point do you think is the stationary point? Which point do you think is the critical point? Which point do you think is the stationary point? I'll give you a better example after this. Tell me. Tell me. Quickly. Which point do you think is the critical point? Which point do you think is the stationary point? Huh? Any idea? Anybody? Any clue? Any clue? See. At x equals 1, this derivative is 0. At x equals 1, this derivative is 0. That much is understood, very clear. When you plug in x as 1, you will get 0 upon something non-zero. That gives you 0 as the answer. So definitely x equals 1 has to be the stationary point. Has to be the stationary point. But at x equals 2, f dash is undefined. F dash is undefined. This means x equals 1 and 2. These are your critical points. Understood? These are your critical points. Got it? Now let me give you another example. Suppose I say f of x is x to the power 1 by 3. And here I say your f of x is x to the power minus 1 by 3. Now you tell me, how many critical points will these two functions have? How many critical points will these two functions have? What will you do? You will find out the derivative. F dash is what? 1 by 3 x to the power 1 by 3 minus 1. So minus 2 by 3. This you can write as 1 upon 3 x to the power 2 by 3. Right? So you can clearly see f dash is nowhere 0, but f dash is undefined at x equals 0. So x equals 0 happens to be a critical point, because critical points are those points where either your derivative is 0 or undefined. So at 0, your f dash is undefined. Here what happens when you compute f dash? What do you get? Minus 1 by 3 x to the power minus 1 by 3 minus 1. So this gives you minus 4 by 3. So here you get minus 1 upon 3 x to the power 4 by 3. Again you can see the same thing happening. Can you see this? Again, you can see the same thing happening. At x equals 0, your derivative is undefined. Right? At x equals 0, your derivative is undefined. That means here also I can say your x equals to 0 is a critical point. Now, what is the scam here? There is a scam here. There is a scam. There is a scam. What is the scam? There is a scam. What is the scam? Can you tell me? There is a scam. What is that scam? What is that scam? The scam is, in the first case, 0 belongs to the domain of f, and hence x equals to 0 being the critical point is acceptable. But in the next situation, your f of x is technically equal to 1 upon x to the power 1 by 3, which means 0 does not belong to the domain of f. And hence 0 cannot be the critical point. Do you see this? We can accept any point as a critical point, stationary point, point of maxima, point of minima, inflection point, only when the point lies in the domain. Please make sure you understand this is a very small note which gets missed by almost every student, because you are in so much hurry to calculate, you're in so much hurry to reach the answer for critical points, stationary points, points of maxima, point of minima, point of inflection, that towards the end you miss out on checking whether the points that you are getting are actually present in the domain or not. Because if they are not, you have to chuck them out, you have to throw them out, kick them out. If they are sitting in the domain, then only you can accept them as answers, as possible solutions. Otherwise, no. So please write this down. Very, very important point and very much neglected, that your critical points, stationary points, please write this down. Critical points, stationary points, points of maxima, minima, or inflection have to come from the domain of the function. They have to, they should, they must come from the domain. Then only they are acceptable. Is it cool? Is it cool? Now, before I jump onto the question, a very last observation. Suppose your f dash happens to be 0 at A. Okay? Then A is an accepted critical point. A is sitting in the domain and your derivative of f is 0 at A. That means A is a very much accepted critical point. Now, what do? This is your A. You plot A. What is written? Examine the sign of f dash on the left neighborhood of A and the right neighborhood of A. Examine the sign of f dash on the left and right neighborhood of A. If on the right of A, strictly on the right of A, the derivative of f has sign positive, and here also it is positive, that means in the immediate neighborhood of A, the graph is strictly increasing. We say f is monotonically increasing at A because my graph is increasing in the immediate neighborhood of A. If suppose derivative has sign negative here, has sign negative here, that means the graph is strictly decreasing at A. That means in the immediate neighborhood of A, the graph is strictly decreasing. Before A, it's decreasing. After A, it's decreasing. That means at A or in the immediate neighborhood of A, I can say the graph is decreasing. If there is a plus sign here, minus sign here, that means the graph is decreasing before A and increasing after A, which makes it a point of local minima. Because the value at A will be less than the values of the input in the neighborhood of A. That's why locally in its neighborhood, at A, we will get the minimum value. Because before A, the graph is decreasing, after A, the graph is increasing. So at A, that means you will get locally minimum value. And that's why A is said to be the point of local minima. On the contrary, if there is a minus sign here, plus sign here, that means the graph is increasing before A, decreasing after A. So that means at A, it is locally acquiring a maximum value. That means A will be declared as the point of local maxima. So these things you can very easily conclude once you have your critical points in picture. Before that, once you have your derivative in picture. So you are given a function, examine its domain number 1, compute the derivative number 2, see where all is it undefined, see where all it's 0. And out of all the answers that you are getting, check which ones are sitting in the domain, accept them as critical points. Next, plot them on the number line. Next, check the sign of f dash about every critical point and then conclude which ones are point of maxima, which ones are point of minima, about which point the graph is increasing or decreasing, which ones are point of inflection. I will tell you how exactly this is done through questions. So let's dive in. Alrighty. Can I start? Look at this question. Look at this question, everybody. Brace yourself quickly. This is a fantastic question. I want all of you all to please pick up your pens and notebooks and start solving. You are given a function. Look here, you're given a function. 4x cube minus 3x square upon 6 minus 2 sin x plus 2x minus 1 times cos x. It's but obvious that the domain of f is set of all reals. Is this cool? The domain of the function is set of all reals. So all real numbers are acceptable. Okay, fine. Now let's compute f dash. We have to talk about it being increasing or decreasing. Let's quickly compute f dash. So 1 by 6 as it is, 12x square minus 6x minus 2 cos x plus, chain rule, 2x minus 1 into minus sin x plus cos x into 2. Making sense? So this gives you 2x square minus x because 6 into 2 is 12 and so on, minus 2 cos x minus this is 2x minus 1 sin x and then plus 2 cos x. So minus 2 cos x plus 2 cos x cancels out. Quickly solve, guys. Quickly, very quickly solve. Very quickly solve. What are you getting? 2x square minus x minus 2x sin x plus sin x. Please check this. Please check this. Yes, so x into 2x minus 1 minus sin x into 2x minus 1. Is this correct? Check the factorization. Check the factorization. This is minus 2x sin x. Yes, okay. So you get 2x minus 1 into x minus sin x. This is where the fun begins. This is where the fun begins. Your f dash is now in picture. 2x minus 1. Look at f dash. Look at your f dash. This is 2x minus 1 into x minus sin x. Now, please make sure you understand that this is a differentiable function throughout the real line. This is also differentiable throughout the real line. So, product of differentiable is differentiable. Why am I telling you this? Because this is nowhere undefined. F dash exists as a real quantity for every x real. So, there is no x for which your f dash is undefined or not defined. So, that means all the critical points that we are going to get as the zeros of f dash only. There are two types of critical points, right? Where f dash is 0, where f dash is undefined. There is nowhere where f dash is undefined. So we only have to compute the points where f dash is 0. So let's take it as 0. This means 2x minus 1 is 0 or x minus sin x is 0. So one critical point we have very easily obtained. It is x equals half. What about this? What about this? What about x minus sin x equal to 0? Please tell me. How will you solve this? How will you solve this? Niresh is saying 0. Anybody else? Anybody else? How will you solve this? This is something which very few students know. Look here. This is your graph of sine, isn't it? This is your graph of sine. I'll draw it here. See. This is your graph of sine x, right? This is 0. Now you draw the line y equals x. This is sine x and this is y equals x. How many of y'all agree? How many of y'all agree that as x tends to 0, sine x behaves almost same as x? As x goes very close to 0, there is absolutely no difference seen between the graph of sine x and x. The graph of sine x almost behaves like the straight line y equals x. In the neighborhood of 0, when you're very close to x, your x and sine x almost behave the same. They almost coincide. They almost coincide. In fact, if you very keenly observe, when x is positive, your x is greater than sine x. When x is negative, your x is less than sine x. That means in the neighborhood of 0, x is equal to sine x only when x is 0. Do you agree? The moment you take x positive, the line is greater than the sine curve. The moment you take x negative, sine curve is lesser than the line. Only at x equals 0, they both actually become the same. Will you remember this? Will you remember this? That means x minus sin x equals 0 gives you x equal to 0. Because x minus sin x equals 0 is nothing but x equal to sin x, which can only happen at x equals 0. So you have two critical points, 0 and half. Now check the sign. Please check the sign. Plus, minus, plus. Check the sign of f dash. Check the sign of f dash about these two critical points. What do you get? What do you get? At 0, it is 0. At half, it is 0. After half, it's positive. Between 0 and half, it's negative. Before 0, it's positive. That means the graph strictly increases, then decreases, and then increases. So f is increasing, not strictly increasing. F is increasing in minus infinity to 0, 0 closed, because f dash equal to 0. That part is included in the increasing definition, not in the strictly increasing definition. Then f union half comma infinity. Is this clear? Is this clear? F is decreasing in 0 half. Is this making sense, guys? Is this making sense? Yes or no? Increasing in half to infinity, yes, it's increasing in half to infinity. Decreasing in half to infinity, no, obviously. Decreasing in minus infinity to half, no, that's not true. Increasing in minus infinity to half, that's also not true. Is it cool? Is it cool? Is this question completely understood, guys? Is this question hashtag HDCC, yes or no? Is this question hashtag HDCC? Very important. Very, very, very important. Alrighty. Let's go ahead. Let's go ahead to the next question. This is the correct answer for this one. Up next, we have this one. Very nice PYQs all these questions are. Very relevant questions which can land in the paper of 2025 JEE Main as well. Please make sure you understand every bit of what I'm explaining. This function is increasing for all x lying in which interval? Again, you can see the domain is set of all reals. Pretty safe situation. Let's compute f dash. Let's compute f dash. Obviously, I will use my chain rule. So first function, differentiation of second 2 by 3 x to the power 2 by 3 minus 1 plus second differentiation of first. So you are getting 3x minus 7 into 2 by 3 x to the power minus 1 by 3 plus 3 times x to the power 2 by 3. Okay, this is 1 upon x to the power 1 by 3. So you can say that 3 times x to the power 1 by 3 is my LCM. 2 times 3x minus 7, and this will give you what? 9 times what? Tell me. X to the power 1 by 3, that means you will just be left with x, 9x. Yes or no? Please calculate. 6x minus 14 plus 9x whole upon 3x to the power 1 by 3. So this gives you 15x minus 14 upon 3x to the power 1 by 3. Please check this out. Please check this out. Are you getting this? Are you getting this? Now, if this is your final f dash, what is your final f dash? Very interesting, very easy, interesting questions. 15x minus 14 upon 3x to the power 1 by 3. Please look here. You can clearly see at x equals 0, your f dash is undefined. So, x equals 0, f dash is not defined. And at x equals 14 by 15, your f dash is 0. Did you understand? At 0, which is a point sitting in the domain, so hence it's acceptable. F dash is not defined. At 14 by 15, f dash is 0. Okay, so both these are acceptable critical points. Yes or no? This is 0. This is 14 by 15. Please understand one thing, guys, very carefully. At 0, f dash is not defined. At 0, f dash is not defined, and hence at 0, I will have to make a hollow circle. At 0, I will have to make a hollow circle. At 14 by 15, it is 0. F dash is 0, so I will make a solid circle because I want increasing. Increasing means f dash is greater than or equal to 0. So I want to know where all is f dash strictly positive and where all is f dash 0. So at 14 by 15, it's 0. After 14 by 15, you can clearly see it's positive. Here it's negative, here it's positive. So increase, decrease, increase. So where all is it increasing? Minus infinity says 0, open. Increasing, union closed, 14 by 15. 14 by 15 comma infinity. This is where all is it increasing. But you can clearly check the intervals in the options. Nowhere it is closed. In the options, you can check nowhere is it closed. That means the question indirectly is asking you to compute the interval where your function is strictly increasing. So this is something you have to take care of by looking at the options. And hence, if we are only interested in strictly increasing, I will not include 14 by 15. This is my answer. Because for strictly increasing, I want f dash to be strictly positive. For strictly increasing, I want f dash to be strictly positive. Okay? Is this cool? I hope there is no doubt till here. I hope there is no doubt till here. All cool, all set? Can I move ahead? Can I move ahead, everybody? Yup. Now let's come to actual high degree, high level question. Tell me, how will you solve this? How will you solve this? Very interesting. F is a function defined by f of x equals this. The interval given to you is x belongs to closed interval 1, 3. Find the interval where function is increasing and decreasing. Now, who will tell me what will get used here? I am only interested in x lying in the closed interval 1, 2, 3. This is my area of interest. This is my interval of interest. I have my f of x given to me as integral 1 to x t square minus 3t plus 2 dt. My very first task, very good Naresh, I'm so proud of you. My very first task is to compute its derivative, and for that I will use my Newton-Leibniz rule. How many of you all remember the Newton-Leibniz rule? Very, very important, people. Very, very important. d by dx of integral, this is f of t dt, t is, let's say, g of x, lower limit, t is h of x, which is upper limit. So your answer comes out to be f of upper limit into upper limit dash minus f of lower limit into dash of lower limit. How many of you all know this? How many of you all agree with this? Is this clear? F of upper limit, I'll write it like this, f of upper limit into upper limit dash minus f of lower limit into lower limit dash. Is this clear? Hi Tejas, is this hashtag Bhoomified? Just like there's Wi-Fi, there's Bhoomify. So there has to be a strong connection between you and me. Bhoomify? Yes? Let's go ahead then. Now, if I'm talking about f dash, so integrand of upper limit, so you will get x square minus 3x plus 2 into derivative of x, which is 1, minus everywhere constant into constant ka dash, which is 0. So nothing will come after this. This is my f dash. Now it's but obvious that if this is my f dash, this is everywhere differentiable. My f dash is nowhere not defined. So I can only get my critical points by checking where all is f dash 0. So what will you get? X into x minus 1, x minus 2 is 0. Yes. Is this cool? This will give me 3 critical points, 0, 1 and 2. It's but obvious, plus minus plus minus. Decreasing, increasing, decreasing, increasing. At 0, it's 0. At 1, f dash is 0. At 2, f dash is 0. Yes or no? So can I say, now you will tell me, can I say that minus infinity to 0 closed, union closed 1 to 2, my function is decreasing? And 0, 1, union 2, infinity, my function is increasing. Can I say this? Can I declare this as my answer? Please tell me. Can I declare this as my answer? Yes or no? Can I declare this as my answer? It's very evident from the diagram. Because I'm interested in increasing, decreasing, I am interested wherever f dash is greater than or equal to 0, and this is wherever f dash is less than or equal to 0. Niresh is saying yes, ma'am. Tejas, yes, ma'am. Harry Potter, Sai, Pragna, yes, ma'am. No, ma'am. No, ma'am. You can only accept points which are lying in your interval of interest or in your domain of interest, which is closed interval 1, 3. When we were talking about critical points, all the 3 critical points that you were getting, 0, 1, 2, were acceptable because they all were lying in 1, 3. Is it true? No. 0 is not lying in 1, 3, so 0 has to be rejected. Only 1 and 2 are accepted. Only 1 and 2 are accepted. And when your interval is 1 to 3, from 1 to, let's say, 3, somewhere here, wherever, 3, wherever. From 1 to 3, from 1 to 3 is your interval of interest. That means in the interval 1, 2, it's decreasing. And in the interval 2, 3, it is increasing. Is this clear? Is this clear? This is the mistake which major students commit. Majority of the students commit this mistake. So they just get very excited looking at the wavy curve method. They get super excited, they get super happy, and they end up committing a blunder. This is not a mistake. This is a blunder. It's a crime. It's a crime, guys. You have to, number one, focus upon the interval of interest or the domain of the function. If there is no particular interval given, domain is what actually comes into action. Okay? Yes, you are correct. You are correct. So please, please, please make sure you focus here. No matter how much clear your concepts are, no matter how much thorough you are with the definition, with the idea, with the conditions, until and unless you don't apply the conditions over the right set of numbers, over the right interval, over the right domain, you will never end up with the right answer. So don't make this blunder. All right? That's why I'm getting these questions solved by you. Also, Newton-Leibniz rule very much gets applied in questions of AOD, so make sure you have a thorough grip upon it. Let's come to this question now. Very interesting, very important. Everybody quickly fasten your seat belts and attack this question. Set of all values of b for which this function does not possess stationary points. For which this function does not possess stationary points. What do you mean? What do you mean? What do you mean? Okay, fine. Harry Potter, noted. 100% noted. Don't worry. Very soon, in fact, next one, I'll try to keep this one only. Tell me. Tell me quickly. What do you mean by function does not possess stationary points? Function does not possess stationary points. What are stationary points? Stationary points are points where the derivative is 0. So when you are saying the function does not possess stationary points, it simply means, yes, you are correct. The derivative is not 0. What are all those values of x sitting in the domain? The domain is set of all reals where your f dash is not 0. So f dash is not equal to 0 is what I need to find out. So let's compute f dash. B square minus 3b plus 2 is to chalo constant. This is your f dash I am computing. Cos square x minus sin square x is nothing but cos 2x. Everybody knows. So directly write its derivative, which is minus sin 2x into 2. Yup. Plus b minus 1 is a constant. Derivative of x is 1. Plus sin 2 ka derivative is 0. So you are getting f dash is equals to b minus 1, b minus 2, minus 2 sin 2x plus b minus 1. How many of you all agree? So b minus 1 is constant. Inside you're left with b minus 2 into minus 2 sin 2x plus 1. Is this cool? Is this cool? Very good. Very good. That means I can say this is b minus 1 and this is 1 minus twice of b minus 2 sin 2x. Now, if I want f dash to not be equal to 0, when is product of two real numbers not 0? Can you tell me? When is product of two real quantities non-zero? When this is not 0 and this is also not 0. Even if one of them turns out to be 0, product will be 0. So if I want the product to be not 0, that means I want each one of them individually to be non-zero. So b is not equal to 1. B should not be equal to 1. And one more thing, that this part should not be equal to 0. That means 1 should not be equal to 2 times b minus 2 sin 2x. Or I can say, yes, definitely b should not be equal to 1. That much is established. And sin 2x should not be equal to 1 upon 2 b minus 2. Sin 2x should not be equal to 1 upon 2 times b minus 2. And what does this mean? What does this mean now? How will I reach to the simplification of this part? That sin 2x is not equal to this. X is real. X is real. When I say sin 2x should not be equal to this, how do you interpret? Please interpret this for me. Please interpret the meaning of this statement. Very important. The entire soul of the question lies here only. Can you tell me? Sin 2x not equal to this. What does this mean? Sin 2x not equal to this. What does this mean? Yes, very good. High five. High five. When you say sin 2x is not equal to this number, this means this number should not lie in the range of sign. If this number, whatever this number is, b is a constant unknown. If this number lies in the range of sign, then definitely there will exist some or the other x for which sin 2x will be equal to this real quantity. But if this number lies outside the range of sign, either it is greater than 1 or less than minus 1, I don't care. But if this number lies outside the range of sign, then I am 100% sure there is no real x for which sin 2x is equal to this quantity. So if I want sine 2x to not be equal to this quantity, equivalently what I mean, this implies 1 upon twice of b minus 2 should not belong to minus 1, 1 closed interval. This means mod of 1 upon twice of b minus 2 should not be less than 1, less than equal to 1. Should not be less than equal to 1. Very good, Naresh. Very good, Harry Potter. Okay, that means it should be greater than 1. This means it should be greater than 1. Yes or no? Or I can say this implies 1 upon 2 times mod of b minus 2. This has to be greater than 1. Or I can say mod of b minus 2 should be less than 1 by 2. This is also something I can say. And I know mod a is less than k means a is greater than minus k less than k. That means b minus 2 is greater than half less than minus half. Greater than minus half less than half. Yes or no? B minus 2 is greater than minus half less than half. That means b will be greater than 2 minus 1 by 2 less than 2 plus 1 by 2. This gives you 3 by 2. This gives you 5 by 2. So you get b belongs to 3 by 2 comma 5 by 2. But this is one of the conditions which has come from here. And another simultaneous condition which has to be true is b not equal to 1 and b not equal to 1. But you can see and means intersection. Intersection will obviously come out to be this only. Because the interval is starting from 1.5. Na? 3 by 2 is 1.5. So obviously 1 doesn't belong in the interval. So what will you remove? The intersection will be 3 by 2 comma 5 by 2. Is this clear? So this is how questions actually come in the paper. They test your knowledge about definition of stationary points. They check that you know or not that critical points, stationary points, points of maxima, point of minima, point of inflection should all come from the domain. If there is some critical point you are getting which is not lying in the domain, then that is actually not an acceptable critical point. It might solve or it might justify the definition of a critical point that f dash is 0 at this point, but because it's not coming from the domain or our interval of interest, we will not accept it as one of our potential critical points to work with. Cool? Yes? Now come to this question. I have brilliant questions lined up for you guys. Brilliant questions lined up for you. Please tell me, do you know how to solve this one? Find the number of critical points. Until and unless the concept of critical point, stationary point, points of inflection, points of maxima, point of minima is not clear to you, you will never be able to feel comfortable and strong over this topic. So tell me, find the number of critical points of this function. Again, logic is the same. Interval of interest is open interval 0, 3. Mind it. Open interval 0, 3. I am interested in f dash. 1 minus 1 by x plus. How will you differentiate this part? How will you differentiate this part? Newton, Leibniz rule. Yes, ma'am? Yes, ma'am? Newton, Leibniz rule. F dash is 1 minus 1 by x plus. Differentiate this. 1 by x minus 2 cos 4x. Into derivative of x is 1 minus, plug in the constant ka derivative is 0. So that is it. That is it. You are getting 1 minus 1 by x plus 1 by x minus 2 cos 4x. This gets cancelled. So you are getting minus 1 minus 2 cos 4x. And remember, x belongs to 0, 3. Now tell me, what will you do? If this is your f dash, what will you do? This means what? You can clearly see this is nowhere undefined. You say a point is critical point when either their f dash is undefined or f dash is 0. This f dash, you can clearly check, is nowhere undefined. It's everywhere differentiable. Minus 1 minus 2 cos 4x is everywhere differentiable. So it's also differentiable in the open interval 0, 3. So there is no x for which this is undefined or does not give real answer. So I can get my critical points only by computing this equal to 0. I'll just put this equal to 0. So minus 1 minus 2 cos 4x equal to 0. So this gives you what? Cos 4x is equal to minus half. Acha. Cos 4x is equal to minus half when x comes from 0, 3. This is, guys, a trigonometric equation. Ma'am, trigonometric equation has been removed from the syllabus. Scam. It's a lie. It's a myth. Trigonometric equation is very much in the syllabus. And this is how it pops up in between the questions of other chapters to make you realize that please do not rely on deleted syllabus. Please, please, please focus on syllabus completion. I know you are not left with too many days now, but still, if you prepare smart, if you just focus on the standard variety of questions which come from the chapters which you left, even that will do the purpose. That will serve the purpose. Believe me. Take a look at the NCERT, take a look at just the previous, I should say 2020, 2021 PYQs. Just catch hold of the standard formulas which get repeated again and again. Just get yourself comfortable with the basics of the chapter, and that's it. This I'm talking about chapters which you have left completely. Don't leave a chapter completely, guys. You will really regret it. The amount of multi-conceptual questions which are coming in math is crazy. This is exactly what is raising the level, the difficulty bar of math. Because the concepts of different chapters are intermingled, intertwined, and being asked in one question. The examiner is literally testing you on the volume of concepts you are clear with. By just asking 1 or 2 questions, it is testing 5-6 concepts of multiple chapters. So how will you be able to pass in that test? Only when you are well versed with so many concepts, and only when you have exposed yourself to such great variety of questions that the questions don't seem shock to you. Questions don't seem like a surprise to you. You experience a sense of familiarity with the question. That actually will give you the confidence to crack it. Got it? Yes? Okay. How will you solve this one? Do you know cos theta equals cos alpha? Theta equals 2n pi plus minus alpha. How many of you all know this? You should know sin theta equals sin alpha solution, general solution. Cos theta equals cos alpha, tan theta equals tan alpha. You must know this. So cos theta equals cos alpha. How to write minus half? Minus half. Cos is negative in which quadrant? Second and third. Pi minus theta, pi plus theta. Where is it half? 60 degrees. That means pi by 3. So pi minus pi by 3 and pi plus pi by 3. When you say 0, 3, this is approximately same as saying 0, pi. So out of the first and the second quadrant, in the second quadrant cos is negative. What is the angle? Pi minus 60 degrees. Pi minus pi by 3, so 2 pi by 3. So this will give you cos 2 pi by 3. So this is like alpha. This is like theta. So theta equals 2n pi plus minus 2 pi by 3. Yes or no? 2 cancels out. This is 2. So x is equals to 1 by 2 times n pi plus minus pi by 3, where n comes from the set of all integers. Is this cool? Is this cool? Or you can say x is equal to n pi by 2 plus minus pi by 6. Now let's start plugging in the values of n and check what are the acceptable critical points we are getting. So when you plug in n as 0, what are you getting? X equals plus minus pi by 6, but we only want in 0 to pi, first and second quadrant. So minus pi by 6 not acceptable. N equals 1, you get pi by 2 plus minus pi by 6. What does this give you? 2 into 3, 4 pi by 6, so 2 pi by 3. And when you do minus 3 minus 1, 2 pi by 6 means pi by 3. Both acceptable. When you plug in n as 2, you get pi plus minus pi by 6. 7 pi by 6 is not acceptable. So you will only accept pi minus pi by 6, which gives you 5 pi by 6. And that's it. That's it. Beyond this, you plug in any value of n, you are going to get values which are not in 0, 3 interval. You will get values which are outside 0, 3 interval, or which are outside the first and the second quadrant. And that is something which we do not want. And hence, acceptable ones are 1, 2, 3, and 4. 4 critical points. How many of you all get this? Your answer, guys, is 4 critical points. Is this cool? Just get the logic correct, just get the basics correct, just get the fundamentals right, and any question of this sort you will be able to smash, crack, smash, kill, conquer 100%. 100%. Come to this one. F of x is x upon sin x, g of x is x upon tan x, where x lies in 0 to 1 interval. Then this question, guys, is a very important result. There are very few people who know this. I want you to please remember this. I want you to please remember this. Please remember this. Now, what is the result? What does the result say? And this question is actually asking you to prove the result. So, number one, when you say f of x is x upon sin x, remember here x is lying in 0 to 1 interval, or you can very comfortably say it's lying in 0 to pi by 2 interval. Very comfortably. That means we are talking about x lying in the first quadrant. That's a safe space to be in. That's a better way to put this. But actually, technically, it's lying in 0 to 1 interval. Okay? 1 is very, very close to pi by 2. So, I'm just making you understand that we are lying in the first quadrant. And corresponding to that, we have to prove. What do we have to prove? To show that f is increasing in this interval. In this interval or in this interval. This is what we have to show. It is increasing. That means I have to show x upon sin x is increasing. That means I have to show f dash is positive in this interval. Equivalently, this is what I have to show. So, if I compute f dash, what am I getting? Second function differentiation of first minus first into differentiation of second upon second function whole square. Now, I know as a matter of fact, when x lies in 0 to pi by 2, sine is positive, square is also positive. So, this is definitely positive. That means I just need to show that the numerator is positive because denominator is already positive. So, I just need to show that sin x minus x cos x has to be positive. That means I have to show what? That your sin x is greater than x cos x, or that your sin upon cos is greater than x, or that tan x is greater than x in the first quadrant. Tell me, is this true? Did you understand the flow? Don't cram anything. Did you understand the flow? If I want f has to be increasing, that means I want it's actually strictly increasing. Not increasing, it's actually strictly increasing. If I want f to be strictly increasing, that means I want f dash to be positive. I computed f dash, denominator came out to be positive. That means I only need to show numerator is positive. Because positive upon positive will give me positive. For numerator to be positive, I actually want to show tan x is greater than x. Do you agree? This is true or not? This is true or not? You remember? This is the graph of tan. This is 0. This is pi by 2. And if you compute, or rather if you draw y equals x, this is how it looks like. At 0, it's a tangent to my tan function. Yes, it's a tangent. So this is y equals x and this curve is actually tan x. I'm only interested in 0 se pi by 2 open interval. You can clearly see tan x is greater than x in the first quadrant. Tan x is greater than x in the first quadrant. Can you see this? Look at the graph. Tan x is greater than x in the first quadrant. If tan x is greater than x in the first quadrant, that means this is true, which means this is true, which means this is true, which means numerator is positive. Positive upon positive gives you positive. That means f dash is positive, which means f is strictly increasing in the first quadrant. And hence you have established your result that x upon sin x is strictly increasing in the first quadrant. And hence it's reciprocal. Sin x upon x is strictly decreasing in the first quadrant. Got it? This is result number 1. Result number 2 is exactly opposite. If x upon sin x is increasing, then x upon tan x will strictly decrease in the first quadrant. You can prove by yourself in the similar manner. And it's reciprocal. That means tan x upon x will strictly increase in the first quadrant. Very, very important results, people. Very, very important results. Very important. Is this clear? Is this making sense? Please tell me everyone, any confusion, any doubt? This one I have proved in a similar manner. You can prove this. Making sense? Hashtag HDCC, high definition crystal clear, everybody. Everyone, please tell me. Is this cool? Yup. Tick. Awesome. Come to this question now. Brilliant. Beyond brilliant. The brilliant question. This is where your concepts are tested. This is actually where your concepts are tested. Read it. Read the statement. Please read the statement. Quickly. F and G are increasing and decreasing functions respectively from non-negative reals to non-negative reals. H of x is f of g of x. Composition, okay? H of 0 is 0. H of x minus h of 1 is what? What do you think? What do you think is the way to approach this question? Anybody? F is increasing. When you say f is increasing, it means f dash is non-negative. G is decreasing means g dash is less than equal to 0. This is true for all x coming from close 0, open infinity. For sure. For sure. Awesome. Now it says, what about h of x? One thing is sure, even h of x is going to be defined from here to here. For sure. This means h of x will give you non-negative answer for every x non-negative. No matter what x non-negative you plug in from the domain, the answer will always come out to be greater than or equal to 0 because that's the codomain. Basics of functions. Next what? H will be decreasing. Are you sure of it? Are you sure of it? So there are two ways to prove. There are two ways to prove what Naresh is claiming. Naresh is saying, ma'am, h of x is actually f of g of x. Now listen to me. When you say h dash, you actually write f dash g of x into g dash x. Now g dash you know is less than equal to 0. G dash you know is less than equal to 0 because g is decreasing. Now x is coming from 0, infinity. G of x is going to go in 0, infinity only. That is the codomain. So g of x, that means, is coming from close 0, infinity. And f dash of anything which comes from here is non-negative. So this completely is non-negative. Greater than equal to 0 into less than equal to 0 will obviously give you less than equal to 0. That means h dash is less than equal to 0, which means h is decreasing over its domain. Another way to prove this, okay, very interesting. Or you can say x1 greater than x2. This is the domain. These are 2 points coming from the common domain. Correct? 0, infinity. Now, I want f of g of x. What about g? G is decreasing. So, g of x1 definitely will be less than equal to g of x2. Now, f is increasing. So, f of g of x1 will be less than equal to f of g of x2. Remember the definition? Whenever we are talking about increasing or strictly increasing, the inequality between input and output is same. The mouth opens towards the same direction. But when we are talking about decreasing or strictly decreasing, the inequality between input and output reverses. It becomes the opposite. So what are you getting? x1 greater than x2, but fog of x1 is less than equal to fog of x2. So whatever is the relationship between input, it's ulta, it's opposite, it's converse is the relation between output, and that too with the equality sign, which again means that h is, or fog is decreasing. Fog is nothing but h, so h is decreasing. These are the two fantastic ways to conclude that h is decreasing. Is it cool? Now what to do? H is decreasing. Okay, let's see now. Now you have to make sure the antennas are up. See, when you say that h is a function from 0, infinity to 0, infinity, it simply means that the inputs are coming from non-negative x-axis and outputs are coming from non-negative y-axis. So the entire graph will only be drawn in the first quadrant. How many of you understand this? Because h is defined from close 0 comma infinity to close 0 comma infinity, this means graph of h lies completely in the first quadrant. Yes or no? This line of non-negative x-axis and this line of non-negative y-axis and everything in the shaded part, all of this is where the graph of h can lie. That's it. Very good. That's it. Now h of 0 is 0. Okay, fine. H of 0 is 0. And h is decreasing. Wait a second. H of 0 is 0 and h is decreasing. If I draw h decreasing like this is a contradiction, because the graph of h should only come in the first quadrant. So what should I do? If h is decreasing, that means the derivative is less than or equal to 0. And the graph has to strictly come in the first quadrant only. Then I can't draw this. There is some problem. I can't draw this. See, when you are saying h dash is less than equal to 0, this means h dash is less than 0 or h dash is equal to 0. H dash less than 0 means h is strictly decreasing. But it cannot be strictly decreasing. Otherwise, it will come something like this. And something like this does not support our argument. It's a contradiction because the graph of h is lying in the first quadrant. So that means h cannot be strictly decreasing. And that means this part has to be accepted. H dash has to be 0. When you say h dash is 0, for all x, h dash is 0. When you integrate, what you end up getting is h of x is equal to 0 plus constant. But you already know h of 0 is 0. So this means c is 0. So h of x actually is 0. This is your h. H is actually the constant function 0, which means the graph of h will look like this. H of x is 0 for all x non-negative. That means the entire non-negative x-axis is the graph of h. This is such a fantastic conclusion. The entire non-negative x-axis is the graph of h, because h is nothing but 0 for all x coming from its domain. This does support the argument that your graph of h is lying in the first quadrant, because your first quadrant is made up with non-negative x-axis, non-negative y-axis and everything in the shaded portion. Is this clear? When your h of x is 0 for every x non-negative, that means h of x is 0, h of 1 is also 0, 0 minus 0 is 0, and hence this 0 is your answer. 0 is your answer. Isn't this fantastic? Like, I loved this question. Loved thoroughly. Brilliant question, yeah. This is always 0. So the answer of h of x minus h of 1 does not depend on x. No matter what you plug in as x, h of x minus h of 1 will always be 0. Because h itself is 0 for every x coming from its domain, which is non-negative set of reals. Is this understood, guys? Is this understood? It's not a very, very easy question, but it's a highly conceptual question, and questions like these are bombarded. Your paper is flooded with such questions. Flooded. Be it JEE Main, be it BitSat, be it your JEE Advanced, any exam you sit for, it's flooded with such questions. Is this cool? Yes? Chalo then. Tell me, very soon we will move on to the next topic. But before that, I want you to tell me the answer of this question. Tell me. Quick. See, we have increasing, decreasing, then maxima, minima, then graphs, tangent normal, rate measure. That's it. But tangent normal and rate measure is not something that I very strongly promote you to spend too much time with. These are very easy concepts. Just get acquainted with a few questions which are important, whose variety is really likely to be repeated, and that's it. You're done with it. I am giving you 1 minute to solve this question. HDCC, Naresh, Harry Potter, Jayvant, Tejas, tell me. Tell me, guys, be active in the chat. Be active in the chat. Of course, it helps me also to be active, and it also helps you gain more and more from the class. Okay? This given function is what? Strictly increasing, strictly decreasing. What is the situation? What is the situation? Quick. After this question, I will give you a tip. I will give you something which is a pearl of wisdom. Very few students know about it, and you will be the one who knows about it. So tell me the answer very quickly. The given function is increasing where, decreasing where? You will do nothing. You will just compute f dash 3x square minus 6x minus 9, 3 common x square minus 2x minus 3. This will give you what? Quickly tell me. X plus 1 into x minus 3. Equate with 0 because this is nowhere not defined. This is also nowhere. Acha, A hai kya? A, Naresh, you're saying A? Let's see. So this is nowhere undefined. So you will get critical points only by putting it equal to 0. This means you are getting x equals minus 1 and 3. Okay, fine, minus 1 and 3. Because you can see the options, it's open interval. We are only interested in strict inequality. That means we are only interested in strictly increasing, strictly decreasing. So here you'll have a plus, then minus, then plus, increasing, decreasing, increasing. That means it's strictly increasing in minus infinity to minus 1, union 3 to infinity. This is strictly increasing and strictly decreasing in minus 1 to 3. Very good. D is also correct, Naresh. D is also correct. You're only saying A. You're only saying A. D is also correct. Yup. This is wrong. This is wrong. A and D. Right options. All right. All right. Come to this question. Now the concept of inflection points comes into action. Of course, I will be explaining this to you in detail as well, but with the help of this question, please understand something which is such a slippery area for students. I can't even begin to explain. This is such a slippery area for students. They always commit mistake in solving such questions and declaring inflection points. Always. Hiding it? What was I hiding? Acha, the options. Look at the options. Okay, my bad. But A and D correct. All right? I hope it's clear to you. It got hidden. Chalo, tell me. So from this question, you will realize that how easy actually inflection points are and what is the concept behind it. Tell me. This function has 2 inflection points. Where is it strictly increasing? Where is it strictly decreasing? Or does it have no inflection points? The very first agenda always, you say h of x is x to the power 1 by 3 into x minus 1. Please realize x is coming from the set of all reals. This is the domain of f. This is very important for you to realize, bache. What is the domain? Very important for you to realize. Now, compute h dash. Nothing happens without h dash. So first function, differentiation of second, plus second into differentiation of first, 1 by 3 x to the power 1 by 3 minus 1. This gives you x to the power 1 by 3 plus x minus 1, 1 by 3 x to the power minus 2 by 3. Correct? So you are getting x to the power 1 by 3 plus 1 by this, you can write it as x minus 1 upon 3 x to the power 2 by 3. X to the power 2 by 3. This is the LCM. This gives you x plus x minus 1. So you are getting 2x minus 1 upon 3x to the power 2 by 3. Guys, you have to be quick like this. You have to be very quick. Very quick. This is 3x. Yes, 3x and x is 4x. Now, please check. Please check. Everybody. Please check what is this written. 4x minus 1 upon 3 times x to the power 1 by 3 ka square. This is what is written technically. Now, All real numbers are lying in the domain. Domain itself is a set of all reals. Where is this 0? Where is this undefined? Can you tell me? Where is this 0? Where is this undefined? So you can clearly check your f dash is 0 at x equals 1 by 4 and your f dash is undefined at x equals 0. Any confusion? Your f dash is 0 at x equals 1 by 4. Your f dash is not defined or f dash is not existing as a valid, well-defined real quantity at x equals 0. Both 1 by 4 and 0 are lying in the domain, so both are acceptable critical points. 0 and 1 by 4 are my two critical points. Look at this. 0 and 1 by 4 are my two critical points. So critical points for f are 0 and 1 by 4. What about the sign change of f dash? Look here. Sign change of f dash. Around 1 by 4, sign will change from positive to negative. But you can see the factor of 0 is x to the power 1 by 3 with a power of 2 which is even. So the sign will not change about 0. Oh, okay. What next? What next? Sign will not change about 0. That means the graph is decreasing and then increasing. So about 0 it's decreasing. About 0 it's decreasing. Okay. Till 1 by 4. After 1 by 4 it's increasing. So 1 by 4 you can clearly see is the point of local minima. No doubt about this. But I don't want this. I am interested in strictly increasing where, strictly decreasing where. So you can clearly see f is strictly increasing in 1 by 4 say infinity and f is strictly decreasing in minus infinity to 1 by 4. So before 1 by 4 it's decreasing, after 1 by 4 it's increasing. This is correct, this is correct. What about inflection points? Anybody, any clue? What is an inflection point? Now many of you know that the point about which f dash does not change its sign is what is called an inflection point. The point about which f dash does not change its sign is what is called an inflection point. This is valid when, do you know? That's okay, Naresh, concavity changes. Inflection points are points where the concavity of the function switches. When your graph is concave up, it becomes concave down. Your graph is concave up, it becomes concave down. So this point says x equals a. This is called the point of inflection. Or it's concave down and it becomes concave up. Then the point at which the concavity switches, say it's x equals a, this becomes point of inflection. Either the concavity changes from concave up to concave down or concave down to concave up. So can I say 0 is a point of inflection? Can I say 0 is a point of inflection? Because derivative is not changing its sign from positive to negative or negative to positive about 0. Can I say 0 is my inflection point? Everybody please tell me. Can I say 0 is my inflection point? If your given function is continuous and differentiable, then if your given function is continuous and differentiable, then if the derivative does not change its sign about a critical point, that critical point can be declared as an inflection point. How many of you all agree? If your given function is continuous and differentiable, for such a function, if there is a critical point about which the derivative is not changing its sign, it's either positive both sides or negative both sides, then that point can be declared as the inflection point. So here what's happening? About the critical point 0, about the critical point x equals 0, f dash is negative. This means f is strictly decreasing about 0. and f is continuous and differentiable. You can check that. F is continuous and differentiable. This implies x equals 0 is a point of inflection. This implies x equals 0 is a point of inflection. Because your derivative is not changing its sign and your function is continuous and differentiable. But mind it, this does not mean that 0 is the only inflection point. If there is a critical point about which derivative does not change its sign for a continuous and differentiable function, then you say that's a point of inflection. But that is not the only point of inflection. Right now, x equals 0 is established as a point of inflection, but this does not guarantee, argument till here does not guarantee, does not make it sure that only 0 is a point of inflection. 0 is, for sure. But is there any more? That is something which is yet to be examined. And for that, I need double derivative. For that, I need double derivative. What will you do? You will compute double derivative. What is that? What is your single derivative? Okay, 4x minus 1 upon 3x to the power 2 by 3. 4x minus 1 upon 3x to the power 2 by 3. Its derivative I need to compute. So 1 by 3 as it is, leave it aside. 4x minus 1 upon x to the power 2 by 3. This derivative I need to compute. So I will get what? Second function, differentiation of first minus first into differentiation of second. So 2 by 3 into x to the power 2 by 3 minus 1. This gives you minus 1 by 3 upon second function whole square. So x to the power 4 by 3. Is this cool? Come on, tell me, is this cool? So you are getting 1 by 3. Inside you have 4x to the power 2 by 3 minus 4 into 2, 8x by 3. Okay, let me write this as 4x minus 1. 1 by 3, and this is 2x to the power minus 1 by 3 into 4x minus 1. So this is 1 upon x to the power 1 by 3, no? This is what it is, na? Upon x to the power 4 by 3. Please tell me if you're getting till here. Nobody should attempt any error in calculation. Please tell me. Is this clear? All right. So 1 by 3 as it is. X to the power 2 by 3. 4 into 3, 12x minus 8x plus 2 whole upon x to the power 1 by 3 into 4 by 3. Is this cool? Please check this out. Please check this out. Please check this out. One more thing you can do which is very convenient, something which I always suggest my students to go for. See, this part is always positive. This part is always positive. X to the power 1 by 3 whole to the power 4 is always positive. Is always positive. But what about the remaining part? So the remaining part is this. Without. So I'll write this here. 1 upon x to the power 4 by 3. Look at the remaining part. What are you getting from the remaining part? 4x plus 2 upon 3 times x to the power 1 by 3. This is the remaining part. Into 1 upon x to the power 4 by 3. Leave it. Leave it. This is your f double dash. H double dash. Yes or no? This is your h double dash. Please check this out. This is your h double dash. Now you have to find out the same thing. Where all is h double dash 0? Where all is it undefined? These two things you have to find out for h double dash. So h double dash you can see is 0 at x equals minus half and it is undefined at 0. So where all is it undefined? Where all is it 0? At 0 and at minus half. Yes, 0 and minus half. 0 and minus half? Yes or no? From here you are getting x is 0 and minus half. At minus half, h double dash is 0. And at 0, h double dash is undefined. 0 and minus half, if you carefully check, this is minus half, this is 0, then about 0 is the sign changing? Yes, ma'am. And about minus half, again the sign is changing. That means h double dash is positive before minus half. That means the function is concave up. Here f double dash is negative. That means function is concave down. Then h double dash is positive, means function is concave up. So the concavity is changing at minus half and 0. Therefore, minus half and 0 are points of inflection. It has 2 points of inflection. This was correct using the first derivative test, and we have reached to the answer of exactly 2 inflection points by using the second derivative approach. Did you understand, people? With so much of detail, I highly doubt if someone will explain you, but did you understand? Please tell me. Please tell me. Look at the calculations carefully. What did we do? What did we do? First of all, we had the function, we computed the derivative, the domain was set of all reals, right? We equated derivative with 0, and we also saw where is it undefined. So we got 2 critical points, 0 and 1/4. We saw where is it strictly increasing, where is it strictly decreasing. 1/4 happened to be the point of minima, local minima. But 0, about 0, the derivative sign was not changing, so we declared it to be the point of inflection. But this is not enough argument to say that 0 is the only point of inflection. We still have to confirm whether there are other points of inflection or not, and for that I will have to move to h double dash. I computed h double dash, I saw where all is it 0, where all is it undefined, depending on my domain, okay? Because my domain is set of all reals, both 0 and half are acceptable. Then I saw the sign change, which implied that where all is the concavity changing, about minus half and 0, so they both are my inflection points. So you saw from the first derivative test only 0 was coming out to be the inflection point, but actually using the second derivative test we realized that even minus half is another inflection point. So in total there are 2 inflection points. Yes, please realize this very carefully before I move to the next question. Please realize this carefully, bache. When you say inflection point, that's the point where concavity changes from concave up to concave down, or concave down to concave up, right? And point of max and point of min, what are they? When the graph changes its nature from increasing to decreasing or decreasing to increasing. One thing please realize, if a point is point of inflection, it cannot be a point of max or min. If a point is a point of max or min, it cannot be a point of inflection. Because when you say a point is a point of inflection, it means concavity is changing, or it means first derivative sign is not changing. When you say first derivative sign is not changing, that means the function is either throughout increasing about the inflection point or throughout decreasing. So the concavity is changing from concave up to concave down, but the graph is throughout increasing or throughout decreasing. The graph about the inflection point, this is the inflection point, the graph throughout the inflection point is either increasing or decreasing. It's not changing its nature from increasing to decreasing or decreasing to increasing. The concavity changes, but monotonicity does not change. Whereas if I talk about this point, say this is x equals b, you can clearly check here what's happening. This is the point of maxima. This is the point of local max. What's happening? Before b graph is increasing, after b graph is decreasing. But the concavity throughout is concave down. The concavity throughout is concave down. So monotonicity is changing about b, but the curvature is not changing. So please remember this. I'm urging you to remember this, that the intersection of points of inflection and points of max min is actually phi. Very important note. Very, very important note. There are no points, commonly inflection points also and points of extrema also. Points of extrema means points of max, points of min. Did you understand? Inflection point is what? Where the curvature changes or concavity changes, but the monotonicity does not change. The graph is throughout increasing or throughout decreasing about the inflection point. So Monotonicity does not change. If monotonicity does not change, means inflection point can never be a point of max or min. Similarly, when you have a point of max min, when does it become a point of max min? When graph first increases, then decreases, or first decreases, then increases. That's what gives you a point of extrema. No, that means monotonicity is changing, but as a result, curvature is not changing. When a graph decreases and then increases, it's concave up. When a graph increases, then decreases, it's concave down throughout. That means monotonicity is changing, concavity is not changing. So in the case of point of inflection, please make a note. Concavity changes, monotonicity does not. Okay, and in the case of point of max, point of min, or points of extrema, what happens? Monotonicity about the point. Monotonicity about the point changes. Concavity does not. Monotonicity changes, concavity does not. Is this clear? Is this clear? Can I move ahead to the next question? Okay, f is given to be a function from closed 0, 2 interval to r, be twice differentiable such that f double dash is positive for all x in 0, 2. If phi is f of x plus f of 2 minus x, then phi is increasing where, decreasing where? JEE Main 2019 PYQ, very important question. And after this question is the homework question. And when I will give you time to brainstorm upon that question, I will tell you a pearl of wisdom. All right. First of all, please tell me, when you have phi of x to be equal to f of x plus f of 2 minus x. X is coming from 0, 2 interval. Okay, fine. What to do? Where all is phi increasing or decreasing? So when you say phi dash, what is this? This is f dash minus f dash 2 minus x. Yes or no? Now if I want phi to be increasing, I want phi dash to be non-negative. That means I want f dash to be greater than or equal to f dash 2 minus x. This is what I want. This is what is my need, my requirement. For phi to be increasing, phi dash has to be non-negative. That means this part has to be non-negative. That means this has to hold true. But please realize, it says f double dash is positive. What do you mean by f double dash positive? This is very interesting. What do you mean by f double dash positive? What do you mean by f double dash positive? It has two meanings. F double dash positive has two meanings. What are they? When you say f double dash positive, number one, it means f dash is positive, which means f dash is strictly increasing. Secondly, when you say f double dash is positive, it means f is concave up. These are two extremely important meanings of f double dash positive. Very good, Naresh. Awesome job done. Very good. F double dash positive, please remember guys, f dash is strictly increasing and f is concave up. Both the things are being depicted by the condition f double dash positive. Cool? Perfecto? So, if f dash is strictly increasing, this means x will be greater than 2 minus x. Yes or no? Yes or no? In fact, f dash is strictly increasing, and here also we can everywhere see open intervals only. So let's just consider open interval. That means strictly increasing case. Let's talk about strictly increasing case. I don't need to put equality. So if f dash x is greater than f dash 2 minus x, this means x is greater than 2 minus x, or 2x is greater than 2, or x is greater than 1. X is greater than 1. So in the interval 0 to 2, look here. This is 0, this is 2, and here somewhere is 1. When x is greater than 1, and obviously that means less than 2, what is happening? Your phi dash is positive. That means your graph is strictly increasing, or phi is strictly increasing in 1 to 2. Phi is strictly increasing in 1 to 2. This is wrong, this is wrong, this is wrong. Where is it decreasing? It's very obvious. Where is it decreasing? For decreasing, you will have less than. Here also less than, but f dash is strictly increasing. So here also there will be less than. When you have strictly increasing scenario for a function, the inequality between input and output matches. Here also less than, so you get less than 1. That means between 0 and 1, phi dash is negative. So B is the right answer. Easy peasy lemon squeezy. Is this cool? Is this hashtag HDCC everybody? Very important, very important, very important. Okay? Hi Yash, so good to see you. Chalo. Now, before we attack this question, I wanted to give this question as a homework question to you, but it's okay. Let's solve this together. But before I do that, I have something to share with you. You know, I always say, and this is something which shocks me, I always tell students that you should keep around 75 to 80 minutes target for mathematics. So what I always tell students is that your safe target should be to allot around 70-75 minutes to mathematics to crack around 12 to 13 questions. That should be your safe spot. Now, how students interpret it is that, okay, if I have to give 75 minutes to solve 12 questions, that means for each question I have around 7 minutes, 6 to 7 minutes, which is a handsome time. But hey, that's a scam. That's where you slip. That's where you're wrong. See, this 75 minutes actually is a collection of time allotted to successful attempts and unsuccessful attempts. When you go ahead to crack a question, you are not compulsorily going to get it right in one shot. It might happen you read the statement, you start imagining, you start thinking how to crack it, that wastes time. Number 2, you start solving, you reach 4-5 steps. After the 5th step, you feel you're stuck. Time waste, you have to move on to the next question. Or you solve the entire question, by the end you realize that my answer is not matching with any option. Again, time waste. So all this wasted time is also a part of this 75 minutes. And it will always be. This wasted time of unsuccessful attempts or failed attempts constitutes to be around 15 to 20 minutes. That means ideally you only have around 50-55 minutes to get those 12-13 questions right, which is a real task. And that is what you have to train yourself for. You have to train yourself accordingly, bachche. You have to expose yourself to a variety of questions so that your question selection improves. You have to practice, but you have to do a timely practice. Practice with a timer on so that you strike a balance between speed and accuracy and you do not waste a lot of time. This 15-20 minutes of failed attempts should be minimized. So please, whenever you're practicing mock tests, solving your PYQs, always keep this in mind that I have to solve 12 to 13 questions in 50-55 minutes. That is my target. And this has to be all the questions correct. 12-13 questions correct in 50 minutes. 12 questions correct in 50 minutes. That is the target. So to get those 12 questions correct, you actually have to attempt 17 to 18 questions. That's the reality. That is the reality. Okay? So that wasted time or the time which you have wasted in unsuccessful attempts or failed attempts has to be minimized. For that, you have to practice. This is something which not very many students know. They only stick with the idea of allotting 75 minutes to 12-13 questions, which means I have 6 to 7 minutes for every question. I will solve our answer. I'll take my time to solve. I'll solve our answer. That's not true. That's a scam. All right? All right? Now, let's go ahead and solve this question. If lambda star, the largest value of lambda for which this function is increasing for all x real, what is f lambda star of 1 and f lambda star of -1 equal to? Please tell me. When you say this function is increasing for all real, first of all, entire set of reals is the domain. When you say your f is increasing, that means your f lambda dash is non-negative for all x real. This is something which is a very, very basic or very natural first step. This is not something which is brainstorming, I believe. So, you are getting 4 into 3, 12 lambda x square minus 72 lambda x plus 36 is non-negative. Yes or no? Please tell me. Tell me. So this will give you 6 lambda x plus 3 is non-negative. So lambda x square minus 6 lambda x plus 3 is non-negative. What does this mean? Anybody? 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 This is a quadratic. Guys, please make sure you understand this is a quadratic in x, quadratic polynomial in x. And quadratic is your favorite chapter. So what does this mean? When you say a quadratic is non-negative, that means two situations arise. Either it's strictly above the x-axis throughout, or it's touching the x-axis at a single point. These are the only two scenarios. Awesome! Awesome! So, when you say ax square plus bx plus c is non-negative, it means a is positive, d is negative, or a is positive, d is 0. Naresh, it can be 0 as well. Because when it's 0, that's when you will get repeated real roots. That's when the parabola will touch the x-axis. And when d is negative, the parabola will rise above the x-axis. It will fly in the air. It will float in the air. So this means lambda is positive and discriminant is less than or equal to 0. How many of you all understand? So from somewhere quadratic has come into action. From somewhere it has popped up, quadratic has come into action. D less than or equal to 0 means 36 lambda square minus 12 lambda. Yes or no? So 12 lambda common, 3 lambda minus 1 less than or equal to 0. 12 vanish, lambda into 3 lambda minus 1 less than or equal to 0. You get 0 and 1 by 3. 0 and 1 by 3 plus minus plus less than or equal to 0 means 0 comma 1 by 3. So lambda belongs to 0 comma 1 by 3. This means maximum value of lambda is 1 by 3. Please check this. Equal to 0 भी तो हो सकता है ना नरेश? It can be equal to 0 as well, less than equal to 0. Yes ma'am, no ma'am? Quickly tell me. 1 by 3 is the maximum value because when you say that lambda belongs to close 0 comma 1 by 3, that means lambda is less than or equal to 1 by 3, no? So it's at max 1 by 3 or at most 1 by 3 or 1 by 3 is its maximum value. So hence lambda star is nothing but 1 by 3. So f 1 by 3 of 1 plus f 1 by 3 of minus 1 is what you need to compute, which is very simple. The answer will come out to be 72. You can compute that by yourself. B is the right answer. Everywhere where there is lambda, just plug in 1 by 3. And everywhere where there is x, plug in 1. Next, plug in minus 1. Add, your answer will be 72. Very easy. This is very simple arithmetic calculation, but I hope you've understood the approach. Is the approach clear? Is the approach of this question absolutely clear, guys? Is the approach absolutely clear? Yes, hashtag HTCC. I'll move ahead. Very important category. Up next is this one. Very important, very nice, beautiful. It's a beautiful question. Beautiful question. Very pretty, very nice, multi-conceptual, and this is going to do a post-mortem, proper post-mortem. F is given to you, F is increasing, F is continuous, F dash 2 does not exist, F has a maximum value at 2. What do you think you will do? What do you think you will do? F of x is written over here. I have to talk about F or F dash or points of max, points of min, increasing, decreasing, max, min value, whatever, in the interval minus 1 to 3. This is my interval of interest, people. Please make sure you understand this is my interval of interest. This is my interval of interest. Is this cool? I am not allowed to go beyond this. All right, let's compute f dash. This is 6x plus 12. Very carefully observe the solution of this question, guys. This question is tricky. It's very easy, Just if your concepts are clear. If not, then this question can literally trap you. You'll slip here for sure. And after that, you'll regret that, oh, this was so easy and I could not decode. You will feel the regret. It's that type of question. So make sure you focus and understand. -1 less than equal to x less than equal to 2. This is 37 minus x. So this is -1. 2 less than x less than equal to 3. Now see, what does the question say? F is increasing in -1 to 2. F is increasing in -1 to 2. So first option, if I talk about x belonging in -1 to 2, my f dash x is 6x plus 12, which means 6 common x plus 2. Yes? Now please realize, if x is sandwiched between -1 and 2, x plus 2 will give you 1 here and 4 here. That means x plus 2 is certainly positive. So 6 times x plus 2 is also going to be positive. Right? That means f dash is positive, which means f is strictly increasing. F is strictly increasing in -1 to 2. F is strictly increasing in -1 to 2 for sure. For sure. F is continuous in -1 to 3. That means in my entire interval of interest, is f continuous? Now see, we all know how to check continuity. We all know how to check increasing, strictly increasing. Everything has just come together in this question. So it might look like a voluminous question, but actually there are different 4-5 questions which has come in just one question. That's the only difficulty of this question. Otherwise, this question is a cakewalk. So listen to me, is f continuous on -1, 3? So from -1 to 2, my function is this, which is polynomial function, definitely continuous. From 2 to 3, my function is this, which is not this. Okay, I'm talking about the derivative. Come here. In -1 to 2, my function is a quadratic polynomial, obviously continuous. In 2 to 3, my function is again a linear polynomial, obviously continuous. But understand, when I need to check the continuity in -1 to 3, I have to check 3 things. First thing, function is right continuous at -1, which means right hand limit at -1 is equal to value of the function at -1. Next, f is continuous in the closed interval -1, open interval -1 to 3. And third, that my function is left continuous at 3, which means left hand limit at 3 is equal to value of the function at 3. Now it's very simple, guys. Please listen to me. It's very simple. My function is right continuous at -1 because whatever is the value of the function at -1, same is the value from the right as well. So this is established. Similarly, my function is left continuous at 3 as well because plug in 3. 37 minus 3 will give you what? 34, which is your value of the function at 3. But from the left hand side, when you will approach 3, again the value is 34 only. So that means this is also established. Between -1 and 2, strictly, I have a quadratic polynomial which is continuous. Between 2 and 3, strictly, I have a linear polynomial continuous. What about the breakpoint 2? What about the breakpoint 2? At 2, my left hand limit is what and what is my right hand limit? At 2, my left hand limit is what? It is 4 into 3, 12 plus 12 into 2, 24 minus 1. This gives you 35. And at 2, my right hand limit is what? Again, 37 minus 2, 35, which is matching. That means on the entire open interval, again, f is continuous. So this means that my function is definitely continuous in the entire closed interval. Did you understand? Did you understand? In the open interval -1 to 2, my function is continuous because it's a polynomial. In open interval 2 to 3, again, my function is continuous because it's a polynomial. But at 2, which is the break point, I will have to check that my left hand limit is equal to right hand limit is equal to value of the function at 2 or not. It was happening. So at 2, which is the interior break point, there also my function is continuous. But because we are given closed interval at the end points, even at the end point, we have to check one-sided continuity. At the left end point, you check right continuity. At right end point, you check left continuity. Even those two are established. And hence, now I can conclude in my entire closed interval, my function is continuous. That's how deep this is. That's how deep this is. Now it says f-2 does not exist. F-2 does not exist. So when you write f dash, what do you get? 6x plus 12. This is -1 less than equal to x less than equal to 2. And this is -1 2 less than x less than equal to 3. Now, f dash 2 from the negative and f dash 2 from the positive. From the left hand side, plug into 12 plus 12 will give you 24. That's the right hand derivative. This is the right hand derivative of f at 2. And from the right, the derivative is minus 1. It's constant. This is left hand derivative. Clearly, they are unequal. Left hand derivative is not equal to right hand derivative at 2. This implies f dash 2 does not exist, or f is not differentiable at 2. Yes, f dash 2 does not exist. F is not differentiable at 2. But what does this mean on an even deeper level? Understand, when you say f dash 2 does not exist, it means f dash 2 is not defined, which means 2 is a critical point for f. 2 is a critical point for f because f dash is undefined there, right? And hence, if I make a number line on the right of 2, what is the sign of f dash? Negative. On the left of 2, what is the sign of f dash? This is left hand derivative and this is right hand derivative. On the left of 2, the sign is plus. Derivative sign is plus. At 2, my function is not differentiable, I agree. At 2, my function is not differentiable. But at 2, my function is continuous. I have established continuity on the entire interval minus 1 to 3. So at 2, my function is continuous, but at 2, it's not differentiable. That means there is going to be a sharp edged turn at 2. Before 2, my graph is increasing. After 2, my graph is decreasing. Are you understanding? Before 2, my graph is increasing. After 2, my graph is decreasing. So you have somewhat situation like this. This is minus 1. This is 2. This is 3. So somewhat the situation is like this. See, the function is continuous at 2, but it is not differentiable at 2, and hence there is a sharp edged turn. Before 2, my function is increasing. After 2, my function is decreasing. Before 2, my function is increasing. After 2, my function is decreasing. Did you understand? How do I know this? Because see, after 2, derivative is negative. And before 2, you plug in any point here, derivative is positive. Moreover, if you compute f double dash, even that you can compute, what will you get? See, before 2, what will you get? What will you get? 6. 6 is positive, that means graph is concave up. Okay, so from minus 1 to 2, graph is concave up. Did you understand? Did you understand? This is a rough sketch of the function. If you want, you can compute exact value of f at minus 1. If you want f at minus 1, this will be 3 minus 12 minus 1. So 2 minus 12 is minus 10 and f of 3 will give you 34. This will give you 34. Okay? Is this cool? 3 minus 12 minus 1. Cool. So the graph will go below the x-axis. It will go something like this. Is it cool? But that doesn't change the fact that my function is increasing before 2 and decreasing after 2. And hence at 2, what is the situation? At 2, I have point of local maxima. Corresponding to the closed interval 1 to 3, at 2, I have point of local maxima, but this is a sharp maxima. This is a sharp maxima because my function is not differentiable at 2. Did you understand? All 4 options are correct. Brilliant question. Brilliant question. Does this make sense, everybody? Made sense? Yes, ma'am? No, ma'am? Does this make sense? Awesome. Now let's talk about point of inflection. I've already told you how do you have to actually perceive a point of inflection. See, always remember when we are talking about point of inflection, there is a very minute detailing involved which makes a point of inflection acceptable. So there are two scenarios technically which you must know. There are two scenarios technically which you must know. What are those two scenarios? Number one, if f is continuous and differentiable, I've already told you, if f is continuous and differentiable such that f dash does not change its sign about the critical point x equals c, then x equals c is accepted as the point of inflection. Suppose I have, let's say my f dash looks like x minus 1, x minus 2, x minus 3 square. So you have three critical points, 1, 2 and 3, plus, plus, minus, plus. Increasing, decreasing, increasing. Correct? This is point of local max, point of local min, and 3 happens to be the point of inflection. Because my derivative is not changing its sign about 3 and my function here is continuous and differentiable. But there is another condition. There is another condition. What is it? Look here. Look here carefully. Tangent exists at this point. F double dash has opposite sign on either side of C, then the point C comma f of C is called the point of inflection. Are you understanding what I'm saying? Are you understanding what I'm saying? See, second condition says f dash C exists and f double dash C is either 0 or not defined, and f double dash changes its sign about C. When your f double dash changes its sign about C, that means f double dash is positive here, then it becomes negative, or about C, f double dash is negative here, here it becomes positive. That means your graph is concave up, then it's concave down, or concave down, then it's concave up. So C is declared as the point of inflection about which technically the concavity is switching, the concavity is changing. Okay. Okay. Did you understand? See, if you want to compute f double dash to should exist, na? If you wish to compute f double dash, which you are finding it out to be 0, if suppose f double dash is 0, that means you are double differentiating the function at C, na? So first of all, the single differentiation should exist, no? That is why it's written f dash should exist. Then if you compute f double dash, if it comes out to be 0 or not defined, then you check, then you accept it as a potential point of inflection, but you will declare it as the actual point of inflection only when f double dash changes its sign about that C. These are the two situations from where you actually get your inflection points. Please don't do the blunder of only declaring these type of points to be inflection points. So what do students do? They actually do some kamchori, okay? They try to save themselves from extra work. What do? They just compute f dash. They see about which point f dash is not changing its sign. That is the list of inflection points. But no, that's not the complete list. To get the complete list of inflection points, you have to go to the double dash. Check about which point double dash changes its sign. That's from where you get the complete list of inflection points. Okay? If you want a complete list of inflection points, always remember you have to deal with double dash. Single dash will not give you complete list of inflection points. Okay? It might happen that from single dash, you don't get any inflection point. Or it might happen from single dash, you might get 1 or 2 inflection points, but still you have to go to double dash to check if there are more inflection points or not. Because only then you will get a complete list, a complete understanding of how many actually inflection points are there. Okay? Keep this in mind. Chalo. These are just some examples of curvature being changed and hence inflection points being produced. But hey, let's take a look at this question, which is going to give a lot of understanding about inflection points. How many inflection points do you think are there of this function? How many inflection points you think are there of this function? Tell me. How many inflection points you think are there of this function? X square e to the power minus mod x. Now, one observation, very important. X square is an even function. E to the power minus mod x again is an even function. Right? Replace x with minus x, you will get the same functions back. That's the basic definition. So both these individual functions are even functions. That means their product is also even. So f, that means, is an even function. When any function is an even function, it means it is symmetric about the y-axis. If it is symmetric about the y-axis, whatever is its behavior on the left of the y-axis, its mirror image is going to be the behavior on the right of the y-axis. And hence, our task reduces. We only need to examine the behavior of f on any one side of the y-axis. Its mirror image will give us the behavior on the other side as well. Got my point? So, what we are going to do is, this implies examine f only with respect to x non-negative. Only on the right of the y-axis, that means corresponding to x non-negative. Only corresponding to x non-negative, you will be examining f. Okay? So, let's start. For x non-negative, what is my f of x equal to? X square as it is, and mod x becomes x. So, this is what you get. Now, remember, domain is just closed 0, open infinity. Okay, right now in this situation. So, f dash you compute. What is it? First function differentiation of second plus second differentiation of first. So, you are getting minus x square e to the power minus x plus 2x e to the power minus x. E to the power minus x comes out common, you're left with 2x minus x square. Okay, x can also come out common. X into e to the power minus x, you're left with 2 minus x. Okay, what next? What next? Because see, you do realize that e to the power minus x, this is always positive. So when you equate this with 0 to get the critical points, you only get x equals 0 and 2. And both of them are acceptable. Why? Because they both are non-negative, which is where I am. That is what is my set of numbers I'm dealing with. So both are acceptable. Now let's plot. This is 0, this is 2. Acha, 2 minus x. So minus, plus, and then again minus. Okay. Decreasing, increasing, decreasing. Which means 0 is the point of local min. 0 is the point of local min and 2 is the point of local max. Okay, fine, cool, understood. But there is no point about which my derivative, first derivative, is not changing its sign. Do you see any point about which my derivative is both sides positive or both sides negative? No. Does this mean there does not exist any inflection point? Can I say this? Does this mean there does not exist any inflection point? Darshan, bachche, Monday. The next part of binomial will happen on Monday, along with some very nice questions. Alright? Tell me, do you think I can now conclude there does not exist any inflection point? Will that be correct? Will that be a correct conclusion? No, ma'am. That's true. Just by examining the first derivative, you can never have the complete information about inflection points. The conclusion of there does not exist an inflection point is completely redundant right now. It's invalid. You can't say this. You can't say this. You will have to deal with double dash. You will have to deal with double dash. So let's start. F double dash. What is f single dash? X e to the power minus x, 2 minus x. Tell me. Quickly tell me. Is this correct? Okay. E to the power minus x, this is 2x minus x square. I want its dash. So first function, differentiation of second plus second, differentiation of first. Cool. 2 common, you have 1 minus x here, e to the power minus x here, plus 2x, or rather x common 2 minus x. There is a minus 1 as well, e to the power minus x. So e to the power minus x comes out common, 2 minus 2x plus x square. So what are you getting? E to the power minus x square minus 4x plus 2. Please tell me, is this what you are getting? This is double derivative. Now, where all is double derivative, 0 or undefined? That's what we have to check. See, single derivative is everywhere existing. There is no point where single derivative is not existing. So, tangent is existing at every point. That condition is met. Now, we just have to check where all is f double dash vanishing and where all is f double dash not defined. So, clearly there is no point where f double dash is not defined. It's polynomial into exponential function. Both are everywhere differentiable, right? But where all is it? 0. So, x square minus 4x plus 2 equal to 0 is what you will get, because this part is always positive, right? I would just need the quadratic to be 0. So, x comes out to be minus b plus minus root over b square minus 4ac upon 2. This is 4 plus minus root 8 upon 2. Root 8 is nothing but 2 root 2. This gives you 2 plus minus root 2. And both of them, 2 plus minus root 2, both of them are non-negative. This is where I'm dealing, no? Both are acceptable. This is where my f double dash is 0. So, I will plot this. This is 2 minus root 2. This is 2 plus root 2. And hence, you will get plus minus plus. So, f double dash is positive here, f double dash negative, f double dash positive. So, this is one point of inflection. This is another point of inflection. These two are my points of inflection in close 0, open infinity. These are my 2 points of inflection in closed 0, open infinity. Is this cool? These are my 2 points of inflection in closed 0, open infinity. That means if my function is an even function, I have it behaving a certain way on the non-negative x-axis. Similar, or rather its mirror image is going to be the behavior on the negative x-axis, which means 2 inflection points on the right, then 2 inflection points on the left. Because if it's changing its curvature 2 times on the right, then it will change its curvature 2 times on the left. At what points, I don't know, I don't care. In fact, it's going to be symmetric points only. It's going to be symmetric points only, but I don't care about the actual value of those points. All I care about is 2 points on the right, 2 points on the left. Total number of inflection points is 4 points. Total number of inflection points is 4 points. It's not 3, it's 4. Number of points of inflection is 4. Is this cool? Making sense, everyone? Inflection points, is the theory clear, the application clear completely? Because now we are moving ahead on a fantastic JEE Advanced PYQ. This is a fantastic, a super simple, trust me, super simple, very easy PYQ. You will think, you can think it's complicated, but actually it's not. You will feel by looking at the question that, okay, it might be complicated, but actually it's not. It's not. Why is it not? Or how is it not? Tell me. Quickly, quickly, quickly. Tell me. Come on, Niresh, Darshan, Yash, everybody, quickly tell me. How is it not? What do you think is the idea involved to crack this question? Tell me. F and G are functions from closed -1, 2 to R. These are continuous functions. Please realize this. Guys, very careful. F and G are continuous functions which are twice differentiable. Very important piece of information that F and G are continuous and differentiable. In fact, they are twice differentiable. When F double dash and G double dash exists, this means F dash and G dash are also continuous and differentiable. This is what it means. When you say F and G are twice differentiable, that means F dash and G dash are continuous and differentiable. Otherwise, they won't be differentiable. Right? Okay. On the interval -1, 2, let the values of F and G at points -1, 0 and 2 be given. So, F of -1 is 3, F of 0 is 6, F of 2 is 0. G of -1 is 0, G of 0 is 1, G of 2 is -1. This is nothing. Cool, that's what the table says. In each of the intervals, minus 1 comma 0 and 0 comma 2, the function f minus 3g double dash never vanishes. Okay, f dash minus 3g dash is 0 has how many solutions? So everywhere it's talking about f minus 3g, f minus 3g, derivative of f minus 3g, double derivative of f minus 3g. One thing let's consider, let h of x be f minus 3g. Chalo, cool. X is coming from minus 1 to 2. Yes or no? Minus 1 to 2? Yes. Now understand, if f and g are continuous and differentiable, clearly f minus 3g is also continuous and differentiable. So h, that means, is continuous and differentiable. In fact, f dash and g dash are also continuous and differentiable. So h dash is also continuous and differentiable. This is also continuous and differentiable. No doubt till here? Okay, fine. Now what? Now what? Question says, very important, f minus 3g double dash never vanishes. What do you mean by this? We are given h double dash never vanishes in the interval minus 1 to 2, or rather open interval. It never vanishes. It's written. In this interval it never vanishes, and in this interval it never vanishes. So what does it say? It never vanishes in minus 1 comma 0 and it never vanishes in 0 comma 2. What does this mean? When you say h double dash never vanishes in this interval and in this interval, this means h double dash is not equal to 0 for any x coming from minus 1 comma 0, and h double dash is not equal to 0 for any x coming from 0 comma 2. But again, what does this mean? How do you interpret this? What is the situation going on? See, h dash is continuous and differentiable. That means if h dash is differentiable, h double dash will exist for every real number in minus 1 to 2. H double dash pakka is existing. It is existing, so there is no input for which h double dash is not defined. We get our inflection points from two situations, when h double dash is undefined or h double dash is 0. Because h dash is differentiable, that means h double dash everywhere is well defined. So to get potential inflection points, we are only interested in h double dash being equal to 0. But it says h double dash is not 0 in minus 1 comma 0 interval or 0 comma 2 interval. This means there does not exist any points of inflection in minus 1 comma 0, and there does not exist any points of inflection in 0 comma 2. That's what it means. That's what it means. And when you say no point of inflection means what? The curvature is not changing. There is no point in minus 1 comma 0 where the curvature of the graph changes. There is no point in 0 comma 2 where the curvature of the graph changes. Which means in 0 comma 1, in minus 1 comma 0, in minus 1 comma 0, throughout the curvature is the same. Throughout the curvature is the same. Similarly, in 0 comma 2. I am not saying in both the intervals curvature is the same. I am saying throughout minus 1 comma 0 there is a single curvature. Either throughout the curve is concave down or concave up. In 0 comma 2 again throughout the curvature is the same. Either it's concave down or concave up. In both the intervals I am not saying the curvature is same. I am saying throughout in one interval curvature is the same. Throughout in the other interval curvature is the same. It can happen in minus 1 comma 0 it's concave down throughout. In 0 comma 2 it's concave up throughout. Or it can happen in both it's concave down, or it can happen in both it's concave up, or it can happen in minus 1 comma 0 it's concave up, in 0 comma 2 it's concave down. So I'm not saying in both intervals it's going to be the same, but all I'm saying is in each interval there is no change in curvature. There is no point of inflection. Cool? Yes, let me come here, very, very important flow. Similarly in 0 comma 2, throughout the curvature is the same. Is this making sense? Yes? Now, if you understood this, question is done. Trust me, question is done. This is -1, this is 0, this is 1, this is 2. At -1, what is the value of h? At 0, what is the value of h? And at 2, what is the value of h? Let's see. F minus 3g, right? So f of -1 is 3. Minus 3 times g. G of -1 is 0. So minus 0. This is 3. What is h of 0? So f of 0 is 6 minus 3. Acha, theek hai. 6 minus 3 will give you 3. And h of 2 is f of 2, which is 0 minus 3 times -1. So 0 minus 3 times -1 is again 3. Okay. So at -1, the value is 3. At 0, it's 3. At 2, again, it's 3. Now, please listen to me carefully. Shinija, the next part of binomial will come on Monday. It will come on Monday as a part 2. Don't worry, it will be there on the channel, and very soon you will see the session scheduled as well. Alright? Now, -1 to 0, you know throughout the curvature is the same. Function h is continuous and differentiable for sure. There is no hole, no break, no gap, no sharp edged turn. Throughout the curvature is the same. That means it will either go like this. Throughout it's concave down. Similarly, in 0, 2, curvature is the same. Again, function is continuous differentiable, no hole, no break, no gap, no sharp edged turn. So, it can also go like this. This is one possibility. Another possibility. Here it's concave down. Here it's concave up. Or another possibility. Here it's concave up. Here it's concave down. Right? Or another possibility. Here it's concave down. Here also it's concave down. So there are 4 graphs. Can you see? Look at the white one, look at the blue one, look at the red one, look at the orange one. Either of these 4 possibilities will take place. This is the graph of h. And you can see in any of these possibilities, there is exactly one point of extrema in -1, 0 interval as well as in 0, 2 interval. These are your 4 possibilities. Let me rub this now. I hope you understood. Suppose this is a situation, then the graph is going to, because it's throughout concave down, it will turn only once. It will increase and then decrease. That means only once will it turn. So I will get only one point of extrema, which is point of maxima in this case, and again point of maxima in this case. So there is exactly one alpha in -1, 0, where the graph is changing its nature from increasing to decreasing or decreasing to increasing, depending upon you've made concave down or concave up. Similarly, there is exactly one beta in 0 to 2 interval where the graph is changing its behavior from increasing to decreasing or decreasing to increasing, because throughout the graph is either concave down or concave up. But there is only one point of extrema in -1, 0 interval. There is exactly one point of extrema in 0, 2 interval. Okay, that means there is exactly one root of h dash in -1, 0. There is exactly one root of h dash in 0, 2. So h dash is 0 exactly once in each interval -1, 0 and 0, 2. It's 0 exactly once in each interval. H dash is 0 means f dash minus 3g dash. So it has exactly one solution here. It has exactly 2 solutions here. No. It has exactly 3 solutions. No. It has exactly 2 solutions here, 2 solutions here. No. B is correct. Fine? Okay? Perfect? Very conceptual question, people. Very conceptual question. I hope this flow is understood. I hope the idea is understood. I hope the concept is understood. Okay? Is this cool? Yes or no? Guys, right now, subscribe to the channel. Everybody who's sitting here watching the session, quickly subscribe to the channel. It just takes a few seconds, not even a few seconds, a fraction of a second. Hit the like button and also subscribe to the channel right now. You're very close to the exam, and we teachers are really working hard to bring the best of the content to you in any way possible, be it through live sessions, be it through recorded videos, be it through YT shorts, whatever, in how much ever way can be useful for you, we are bringing it on the channel. Some of the other teacher will come and give you the information which is very much essential for you. That is for sure. You are taken care of with great set of teachers. So make sure you do not miss out on even a minute detail which gets uploaded here on the channel. And that is why I'm asking you to please subscribe. Stay subscribed and also hit the like button. Okay? Can I move ahead? This people is a JEE Advanced PYQ. Tell me, what will you do? Quickly tell me. How do you think you will attack this question? Thank you, Naresh. Tell me. F is from open 0, infinity to R given by this. Is F monotonically increasing? Is F monotonically decreasing? What about the option C? What about the option D? What do you think? Quickly tell me. It is a JEE Advanced PYQ. Tell me. Obviously, we'll start computing F dash. That's our dharma, that's our karma. So what is F dash? Tell me. Anybody? Which concept do you think will be used? Huh? Naresh, Shinija, everybody watching. Which concept do you think will be used? There's something I want to hear. What is it? We have used it before. Yup, you are correct. It's the Newton-Leibniz rule. Absolutely correct, bache. Absolutely correct. It is the Newton-Leibniz rule. Let's quickly use this. So F dash means what? This will give you e to the power minus of x plus 1 by x. Okay. Upon x, derivative of x is 1 minus. Now you put 1 by x, e to the power minus of 1 by x plus x whole upon 1 by x. Okay. And what is the derivative of 1 by x? It's minus 1 by x square. So minus will make it plus. Correct? You are getting e to the power minus of x plus 1 by x whole upon x plus x here, then e to the power minus of x plus 1 by x upon x square. So this x cancels out. What are you left with? E to the power minus of x plus 1 by x upon x plus e to the power minus of x plus 1 by x upon x. So twice of this. Yup, you're correct. Twice of this. Is this cool? Twice of this. Twice of this. All right. Now, listen to me carefully. X is coming from open 0, infinity. That means x is positive. X is positive. E to the power any real number positive into 2 positive. So, positive upon positive will give you positive outcome. F dash is positive means F is strictly increasing in your open 0, infinity. If in open 0, infinity it's strictly increasing, that means in 1, infinity it is definitely increasing because it's a subset of 0, infinity. Yes or no? It's a subset of 0, infinity. And if it is increasing after 0, it cannot decrease in 0, 1. Right after 0, from 0 onwards, it's strictly increasing. So in 0, 1, it can't decrease, right? It has to increase. Correct? Yes? Theva darshan. Yes. Cool? Done. What about option C? F of x plus f of 1 by x is 0. Okay, let's see. What is f of x? Integral 1 by x to x e to the power minus of t plus 1 by t upon t dt. This is f of x. F of 1 by x is what? Here x, here 1 by x. E to the power minus of t plus 1 by t upon t dt. So this looks like integrand is the same. Can you see this? Integrand is the same. C is correct. This is correct. This is wrong. What about C? C is correct. Integrand is same, guys. Integrand is the same. This looks like integral a to b f plus integral b to a f, which I know is 0. Remember the interchange of limit property? What did it say? It said integral a to b f is equal to minus of integral b to a f. That means when you add both of them, the right hand side will be 0. C is absolutely correct. What about D? It says f of 2 to the power x is an odd function. When you say f of 2 to the power x is odd, that means you have to show when you replace x with minus x, what happens? Minus comes out. F of 2 to the power minus x is what? What do you mean by this is odd? What do you mean by this is odd? This should be minus of f of 2 to the power x. This is what I have to show. This is what I have to show. So what will I use? I will use the fact which is option C. The fact established with option C, f of x plus f of 1 by x, guys, is 0. Now, if x comes from 0, infinity, but obvious people, 2 to the power x also comes from 0, infinity. How many of you all agree? 2 to the power x graph looks like this. If x comes from 0, infinity, 2 to the power x also comes from 0, infinity. In fact, it comes from 1, infinity. Yes? Positive. Basically, in this relationship, I can replace x with 2 to the power x. Not a problem. Because this relation is true for every x positive. Now, 2 to the power x is also positive, na? So, I can replace, I will get f of 2 to the power x plus f of 1 upon 2 to the power x is 0. Which means f of 2 to the power x plus f of 2 to the power minus x is 0. Or f of 2 to the power minus x is minus of f of 2 to the power x. This means this is an odd function. That's what I told you. This is what I had to show. So it is an odd function. D is also correct. Such an interesting question. It is a JEE advanced question, guys. It's a very Purana, very old JEE advanced question, which is highly potential to land in your paper. Somewhat like this can come in your paper because it's a very potential, highly potential JEE Main question. Cool. There was nothing in the question as such. I don't think there was anything very typical in this question. There wasn't. I don't think so. Just compute the derivative, find out where it's positive, where it's negative. Then use the interchange of limit property, which helped us compute the validation of option D as well. So pretty good. Pretty good, right? Easy peasy. Easy peasy lemon squeezy. Look at this question now. This is very but obvious observation. Look here carefully. Whenever your function is differentiable and invertible, you know as a matter of fact, when you plot the graph of the function, look here. This blue color graph is the graph of f inverse and the green color graph is the graph of f. What is it that I'm trying to imply? If you draw the green graph, can you see? The green color might be getting keyed, but understand, if you draw this white graph, let's say, this white graph is f and f is differentiable and invertible. How to compute the inverse? What is the shortcut? Ma'am, you draw the line y equals x. This line y equals x actually acts as the mirror. This line y equals x actually acts as the mirror, and when you take the mirror image of f about this line, what you end up getting is the graph of f inverse. That's the logic. You have the graph of f. It is invertible, so inverse exists. How to get the graph of f inverse? You draw the line y equals x. That line will act as the mirror. About that line, you take the image of f, you will get the graph of f inverse. Now, what is the observation? If f is monotonically increasing, its inverse will also be monotonically increasing. But if f is concave up, inverse will be concave down. The monotonicity will not change, the curvature will change. That is what I want to communicate from this slide. The monotonicity will not change. If derivative is positive, even for inverse derivative will be positive, monotonically increasing. But if double derivative for f is positive, double derivative for f will be negative. curvature will be opposite. Okay, keep this in mind. Whenever your f is invertible, you will realize when you plot the graph, if f is increasing, inverse will also increase. If f is decreasing, inverse will also decrease. But the curvature of both these functions will be opposite. F is concave up, f inverse will be concave down. F is concave down, f inverse will be concave. Monotonicity same, curvature opposite. Monotonicity same, concavity opposite. Cool? Cool? Now let's come to something very interesting, guys. Look here. If f and g both are monotonically increasing, this is something super simple, very, very chindi. What can you say about the monotonicity of fog, goff, foff and gog? Fog, goff, foff and gog. This is somewhere, my tongue is slipping. This is kind of a tongue twister. Fog, goff, foff and gog. What can you comment about their monotonicity? Any comments? See, it's very simple. Let's talk about fog. Okay, let's talk about fog. It's very simple. Say x1 is greater than x2. Fog means you start with g. G is increasing. So g of x1 will be greater than equal to g of x2. Now you go to f sitting outside. F is also increasing. So f of this will be greater than equal to f of this. Which means fog of x1 is greater than equal to fog of x2. You started with greater than, you are ending with the same inequality. That means your fog is monotonically increasing. How difficult was this to prove? Similarly, GOF, GOF will also be monotonically increasing. FOF also, GOG also. Do you understand how to prove this? This is how you have to prove. Very simple. Exactly, here is an example as well. Here, exactly in the same manner, look here. What does it say? F and G both are monotonically decreasing. What can you comment about, let's say, GOF? So let's say x1 is less than x2. Now in GOF, F is sitting inside and F is monotonically decreasing. So F of x1 will be greater than equal to F of x2. Then comes the turn of G. G is also monotonically decreasing. So again, inequality will be opposite. G of F of x1 is less than equal to G of F of x2. Now see, started with less than, ended with less than. That means it's monotonically increasing. Yes, it's monotonically increasing. That's the outcome. When both F and G are increasing, all the compositions are increasing. When both F and G are decreasing, even then all the compositions are increasing. But if one is increasing, one is decreasing, then what happens? Let's see, FOG, let's calculate. So x1 greater than x2, first is the turn of G. G is monotonically decreasing. So G of x1 will be less than equal to G of x2. Next is the turn of F. F is increasing. So F of G of x1 will be less than equal to F of G of x2. What's happening? Started with greater than, ended with less than. Inequality opposite, this is monotonically decreasing. Similarly, GOF will also monotonically decrease. But FOF, guys, FOF. See FOF, x1 less than x2. F is increasing. So F of x1 less than equal to F of x2. Again, F is increasing. So F of x1 less than equal to F of x2. Started with less than, ended with less than, that means monotonically increasing. So this is very simple to prove, people. Please understand, whenever both F and G are increasing, all compositions are increasing. When both F and G are decreasing, all compositions are again increasing. When one is increasing, one is decreasing, this is the scenario. Fog and GOF are decreasing, but FOF and GOG are increasing. Okay, this is a very important previous year question. Very important. And you will realize that just based upon such a fundamental concept, such a fundamental idea, you're getting this question in the paper. F and G are continuous functions. F of x1 greater than F of x2, G of x1 less than G of x2 for all x1 greater than x2. Definition is given to you loudly. If your x1 is greater than x2 and you are given that F of x1 is greater than F of x2, this means F is strictly increasing. How many of you all understood? Increasing. And it's also given x1 greater than x2 implies G of x1 is less than G of x2. This means G is strictly decreasing. Yes, ma'am? F is strictly increasing, G is strictly decreasing. What about fog? Because here it's written F of G, F of G. If F is strictly increasing, G is strictly decreasing. What about fog? We just saw if F is strictly increasing, G is strictly decreasing, fog is decreasing. You can again check, not a problem. It's given x1 greater than x2. You want F or G, start with G. G of x1, G is what? Decreasing. G of x1 less than G of x2. Now F is increasing, so F of G of x1 will be less than F of G of x2. Okay, started with greater than, ended with less than. That means fog is strictly decreasing. And if fog is strictly decreasing, what do you mean? If your fog is strictly decreasing, what do you mean? See, you are given fog of alpha square minus 2 alpha is greater than fog of 3 alpha minus 4. So this is like x1 and this is like x2. And fog is strictly decreasing. So x1 will be less than x2, no, in the next step. X1 will be less than x2, no, in the next step. So what do you get? Alpha square minus 2 alpha will be less than 3 alpha minus 4. That's it. Alpha square minus 5 alpha plus 4 is negative. That's it, people. That's it. That's it. Tell me if you understood. Tell me if you understood. Alpha square minus 4 alpha minus alpha plus 4. So alpha minus 4 minus 1 alpha minus 4. So alpha minus 1 into alpha minus 4 negative. Use your wavy curve method. This is plus minus plus. Alpha belongs to 1, 4. That's your answer. Alpha belongs to 1, 4 is your answer. This is a very basic question just based upon the monotonicity of a composite function. How does it get impacted by the monotonicity of individual functions? Okay? Cool? Come to this question now. Just a couple of more questions, then we'll be starting with Maxima and then moving on to graphs. Very exciting part left. Very, very exciting part left. And I'm super excited. F is given to you, G is given to you. Which of the following is correct? FOF, GOG, FOF, FGOF. Now this is very intuitive. Why intuitive? First of all, you see that F dash X is what? This is cos X plus 2. Obviously positive, which means F is strictly increasing. No doubts about this. What about G dash? This is minus sin X minus 3. Obviously negative. So G is strictly decreasing. Yes or no? If F is increasing and G is decreasing, if F is increasing and G is decreasing, FOF is increasing and GOF is decreasing. Aren't both these true? This is the wrong. This is also wrong. Remember the table. When F is increasing, G is decreasing. I'll show you the table. Wait. When F is increasing, G is decreasing, FOG and GOF are decreasing, FOF and GOG are increasing. So here what is written? What is written? See. FOF should be increasing, it's written decreasing. GOG should be increasing, again it's written decreasing. FOF is increasing, correct. GOF should be decreasing, it's correct. So C and D are correct. That's how easy question becomes once you know how the monotonicity of individual functions impacts the monotonicity of the composite function. Alrighty? Alrighty? Let's attack this question now. F of X is given to you, G of X is given to you. Now tell me, H of X, which is fog of X, is increasing where? Now when you compute fog of X, how do you write? Fog of X is your H of X. How will you write? F of G of X. That means e to the power G of X minus G of X. That's what it will become. No, carefully observe. So e to the power x square minus x square minus x. Please tell me if this is correct. If you understood this, please tell me. Yes? So h dash, let's start. E to the power x square minus x into 2x minus 1 minus 2x minus 1. So 2x minus 1 comes out common. You're left with e to the power x square minus x minus 1. Obviously, this h dash exists everywhere because h is throughout differentiable. You can check polynomial into exponential minus 1. Obviously, this is everywhere differentiable. So I will get my critical points only by equating this with 0. Right? Now, this gives me x equals 1 by 2 and it also gives me e to the power x square minus x equal to 1, which is e to the power 0. So, you get x into x minus 1 is 0. You get x is 0, comma 1. So, you have 3 critical points, 0, 1 and half. You have 3 critical points. Let me write it here. You have 3 critical points, 0, 1 and half. Now, tell me. 0, 1 and half. Half ke about obviously plus minus. 1 ke about again minus, then plus, then minus. So decreasing, increasing, decreasing, increasing. Okay, increasing means, and obviously all the points are acceptable, right? 0 is acceptable, 1 is acceptable, half is acceptable. Where all is it increasing? Closed half, open infinity, and closed 0, closed 1. Tell me which is the correct option. Tell me which is the correct option. Tell me quickly which is the correct option. It's increasing in 0, 1 union half, infinity. Look at option D. I feel option D is correct because half will lie somewhere here. And yes, it is increasing in 0, half for sure. And 1, infinity. 1, infinity is wrong. No, 1, infinity is wrong. It's not increasing in 1, infinity. Which option do you think is correct? Oh, I've made ulta. Oh, I've made ulta. Okay, I'll draw it again. See, this is 0, this is half, and this is 1. Plus, minus, plus, minus. Okay? Decreasing, increasing, decreasing, increasing. Now, you know it's increasing in 0, half, union 1, infinity. Now, D is correct. Alright? Now, D is correct. Is it cool? That's how simple question becomes of composite functions. Because now you know how individual functions monotonicity impacts the monotonicity of the composite function. Okay? Easy? Now, let's get started with something real, something serious. Which of the following statements is or are correct for this function? What do you think? Now, it's talking about concavity. It's talking about inflection points. You already know what these are. You already have learned how to compute them. You already know what do they actually represent and how do they look like in a graphical sense. So, what would you like to say? What would you like to say? See, whenever you need a break, tell me. I will give you a short break. But before entering graphs, I want to complete this portion. Before entering graphs, I want to complete this portion. Tell me. Tell me. Come on. Think. It's something which is in your comfort zone. Don't feel this is outside your comfort zone. It's kind of entering graphs in a very indirect manner. See, f of x is given to you. All you know you have to do is first of all compute f dash for sure. No doubts about this. So you compute f dash. This will give you 4x cube minus 18x square minus 108 into 2 plus 57. Oh, this is x into 2x plus 57. Obviously, set of all reals is the domain. It's a biquadratic polynomial function. Very safe zone to play. Tell me. Okay, f dash. Now, if I want to compute zeros of f dash, that's my target. This function is everywhere differentiable. So equal to 0, where all is occurring, those are my critical points. But now this is a cubic polynomial. Equal to 0 is a difficult task. That's a difficult task. Equal to 0 is now a difficult task. Cubic polynomial equal to 0, that means I have to first of all use hit and trial to get one of the zeros. Then that will give me a factor. I will use the long division method, get a quadratic polynomial, factorize it, get 2 more factors, 2 more roots. That will give me all the critical points. So much hard work. In such a situation, when you have derivative coming out to be a cubic polynomial whose roots it's really difficult to compute, what do? What do? You use the trick to apply f double dash. You use f double dash. What does this come out to be? 12x square minus 36x minus 108 into 2. Check this, please. Check this quickly. Getting this? Let me make the polynomial something simpler for you because there's no need getting indulged in such difficult computations. You can write this as x to the power 4 minus, just change the polynomial, x to the power 4 minus 4x cube plus 12x square minus x plus 1. Or yes, make it like this. Again the same dikkat will come. Again the same problem will come. You make this x to the power 4 minus 4x cube plus 12x square. I am just making life simple for you. Concept is exactly the same. Plus x minus 1. Tell me. Same explanation. Absolutely same. This will give you 4x cube minus 12x square plus 24x plus 1. So f double dash will come out to be 12x square minus 24x plus 24. This will give you 12 common, x square minus x plus 2. And what is it about x square minus x plus 2? You can clearly see this quadratic polynomial has leading coefficient 1 which is positive and discriminant is negative. That means this quadratic's graph, if you draw, it will be above the x-axis throughout. So this complete expression is positive for every x real. Am I making sense, everyone? Am I making sense? This quadratic polynomial's graph is throughout lying above the x-axis strictly. Getting my point? Into 12. That means everything is positive. If f double dash is positive, what does this mean? I wanted to examine critical points, but that was becoming difficult for me because cubic polynomial equal to 0, who will solve? Why should I do so much hard work? So I used my easy way. I tweaked things a little. I involved f double dash. F double dash is coming out to be positive. When you get f double dash positive, this implies f is concave up for all x real. Oh, f is throughout concave up. Now, few things which you must know. Few things which you must do. X to the power 4 minus 4x cube plus 12x square plus x minus 1, right? Few things which you must do if you want to draw the graph. First of all, as x tends to infinity and as x tends to minus infinity, where is the graph going? Because this is a biquadratic polynomial, even degree. As x approaches infinity, graph will go up infinitely. F goes to infinity. And as x approaches minus infinity, even then the graph will keep approaching upar, above, approaching infinity. So again, f approaches infinity. So from both directions, graph will go infinitely up because it's of even degree, biquadratic polynomial. Secondly, let's compute the value of f at some familiar points. F of 0 will give you minus 1. Correct? That's it, I guess. F of 1 also you can compute, but it's okay. It's okay. This means if f of 0 is minus 1, all right, I am very close to the graph, I guess. See, f of 0 is minus 1 and it's infinitely going up. It's infinitely going up. How will be the graph? F of 0 is -1. The graph is infinitely going up from both directions and it's throughout concave up. Also, when you say f double dash positive, this also means f dash is strictly increasing. That means you have your f dash increasing. F dash is going to change from negative to positive. Then only f dash will increase. That means first the graph have to decrease, then the graph has to increase. When the graph first decreases, then increases, that's where we say that the slope is negative, then the slope is positive. So f dash is decreasing, then increasing. That's how it is strictly increasing. And yes, that's why the graph is going to look something like this. U-shaped graph. It's throughout concave up. It is approaching infinity from both directions. As x approaches infinity, graph goes up. As x approaches minus infinity, graph goes up. And that is why it is cutting the x-axis twice. It has exactly 2 roots. It has exactly 2 roots. It has exactly 2 roots. Is this making sense, people? Did you understand? Did you understand? Now we are entering the zone, finally we are entering the zone of plotting the graph. Tell me, are you excited? Now is the time to do something which a lot of students are scared of and where I would, trust me, love to guide you. I would love to guide you. Tell me. Can we start? And if you want to target this question, because this question did not talk about roots, you can just check. If you compute f dash, you will get 4x cube minus 18x square minus 216x plus 57. This is f dash, which is cubic. Compute f double dash, 12x square minus 36x minus 216. Right? Yes. So 12 comes out common, x square minus 3x minus, I guess, 7. No. Okay. When you factorize this, what do you get? Tell me. 12. When you factorize this inside quadratic polynomial, what do you get? 18. What do you get? Tell me. It's very simple. Tell me. Minus 6x plus 3x minus 18. X minus 6 plus 3 into x minus 6. So x minus 6 into x plus 3. Equal to 0, you are getting 2 points, 6 and 3. 6 and minus 3. Okay, 6 and minus 3. Minus 3 here, 6 here, plus, minus, plus. These are roots of f double dash. So concave up here, concave down here, concave up here. That means minus 3 and 6 are your points of inflection. Minus 3 and 6 are your points of inflection. Concave down here, that's correct. Concave up here, that's correct. Concave up here, that's wrong. Yes? Cool? Okay, guys, look here carefully. I want you all to listen to me with your ears open, eyes on the screen, glued. Now we are entering the zone of plotting the graph. I have somehow given you a hint as to how to draw the graph by modifying the previous question. I just wanted to take an opportunity to show you how I think about graphs. So whenever you are plotting the graph of a function, because that topic of solving questions of AOD using graphs is something which lies at the heart of the chapter. Of course, there is max min, of course, there's increasing, decreasing, and of course, there's graphs. Graphs has to be the heart of the chapter. What do you have to do? Number one is determine the domain of the function. If the domain is non-negative reals, you will only draw the graph corresponding to the non-negative x-axis. So number one, you should know corresponding to what portion of the real line I have to draw the graph. Don't start drawing blindly. Like log function, you know, is only well defined for positive x-axis. So you only draw the graph of log corresponding to positive x-axis. Right? That's what you do. So number one, please determine the domain. Number two, please remember, always examine as x tends to infinity, f tends to what? As x tends to minus infinity, f tends to what? So corresponding to the infinite behavior of the x-axis, as x approaches infinity, minus infinity, where is f approaching? Very important. Number three, compute value of f at certain standard points. Right, like f of 0, f of 1, f of minus 1. Depends upon what the definition is. We will be computing some values of f at certain points to get a hang of how, where the graph is touching, crossing, meeting, intersecting, just for that. Number 4, of course, you will be differentiating the function, because until and unless you get the nature of f dash, you will not be able to determine where the function is increasing, where is it decreasing, where is it taking turns, how is it turning. All of that you will not be able to determine. So of course, compute f dash, determine the critical points, determine the points of max, points of min. That will give you the interval of monotonicity. Okay, where is it increasing, where is it decreasing? Now, concavity, according to me, is not that important. If you want to actually reach the graph, what is the actual graph like you see in Desmos or other softwares, for that you need concavity. But concavity will not change the number of roots. If you draw the graph, let's say you draw the graph like this. It's cutting the axis, x-axis once. Now, let's say you find out after solving that this is a concave up graph. If it's concave up, it will go like this, but still it will intersect the x-axis once only, na? So, knowing about concavity will not change the number of roots. And hence, concavity will only give you the actual trace of the graph. We are not interested in actual trace. We are interested in rough trace, which should give us accurate answers. So, concavity is something which, according to me, is not that important. Next, find the value at all critical points and at the end points. So, sometimes you are given closed interval. Sometimes you are asked to consider a closed interval. In that case, definitely compute the value of f at the end points. This is very important. Okay, get it? Correct? Awesome. So all of this is something which is very intuitive, but I wanted to put down in one page on one sheet so that you know, okay, these are all the points I have to consider before plotting the graph. Now it's time to dive into the discussion of graphs, guys. Are you ready? Are you absolutely ready? I want all of you all to pay full attention here on this question. Very, very, very important. Find the interval of monotonicity of this function and plot its graph. Now, the question will not come like this, that plot its graph, but I want you to understand how am I plotting the graph of this function, because once the plot is completed, after that I ask you any question based upon this function, you will be able to answer. You will be able to answer. So let's start. We're going to do a post-mortem of this function, and you have to stick with me throughout, because if you understand the plotting of graph of this function, never in your life you will face problem in plotting the graph of any function. So let's start. F of x is given to you as 2x square minus log of mod x. Now the problem here is you have log of mod x. You know x square or mod x whole square is the same. Either you write x square or mod x whole square, it's the same. So instead of treating this as f of x, let's treat this as f of mod x. Okay. Let's treat this as f of mod x. Okay. Just for convenience. Just for convenience, because everywhere it's looking like I have replaced x with mod x. Cool. So what are we going to do is, we will first plot the graph of f of x, which is 2x square minus log x, and then transform it to f of mod x, which is our required curve, which is our required function or required curve. Cool. So this is where we start with. Perfect. Now, look here. Keep looking. F of x is 2x square minus log x. You know, 2x square has domain as set of all reals, but log x has domain as open 0, infinity. Whenever we have sum of two functions or difference of two functions, the domain is the intersection of the two domains. So, the domain of f is nothing but open 0, infinity. Cool. Is this cool? I'm talking about f of x. The domain is open 0, infinity. So strictly on the strictly positive axis, I will be drawing the graph. Chalo, cool. So we only have to confine our graph plotting to this portion. What is my f of x? It is 2x square minus log x. Chalo. What next? I told you. As x approaches infinity, what is happening? As x approaches 0, what's happening? Because see, now my interval is 0, infinity. Don't blind yourself with, ma'am said x approaches infinity and x approaches minus infinity. Arey Baba, x is not approaching minus infinity. No. It's just 0, infinity. So I am interested, because in open interval, I am interested in x approaching infinity, then function is going where? X approaching 0, then function is going where? Right? So let's start. 0, infinity is this, right? 0, infinity. So this is open circle. This is what is my interval of interest. Now see, as x tends to infinity, what's happening? As x tends to 0, what's happening? Let's first say when x tends to 0 from the right, because it's 0, infinity, you will come to 0 from the right. As x tends to 0 from the right, 2x square definitely tends to 0. But what about log x? What about log x? See, this is how log x behaves. This is how log x behaves. If you go to 0 from the right, log x will go to minus infinity. If you go to 0 from the right, log x will go to minus infinity. So 2x square goes to 0 and log x goes to minus infinity. That means this goes to plus infinity. So f approaches plus infinity. As you go to 0 from the right, function goes to plus infinity. As you go to 0 from the right, function goes to plus infinity. Okay, fine. As you go to infinity, function is going to infinity minus infinity, which I don't know is what. So let's leave that. But as you go to 0 from the right, function is going to plus infinity. Chalo, cool. What about f dash? F dash will be 4x minus 1 by x, which gives you 4x square minus 1 whole upon x. Oh. Now, listen to me carefully. What are you getting as the critical points? 0 and plus minus half. You are getting 0, half and minus half. At 0, f dash is not defined. At half and minus half, f dash is 0. But I will accept only that point which lies in my domain of interest. 0 is not lying here, minus half is not lying here. So only half is my accepted critical point. So half is my accepted critical point. Getting it? Getting it? Yes, ma'am, no, ma'am. Getting it? Obviously, the sign will be plus, minus, decreasing, then increasing. This is the point of local minima. This is the point of local minima. So before half, my graph is decreasing. After half, my graph is increasing. Acha, cool. Okay, fine. This is the only point where the turn is happening. This is the only point where the turn is happening from decreasing to increasing. This is the only point of extrema. If this is the only point of extrema, that means I feel the concavity is not changing. Because when you have a single point of extrema, that means the graph is turning only once. If the graph is turning only once, be it like this or like this, that means it's throughout concave down or throughout concave up. That is what my logic says. That is what my concept says. That is what my analysis says. If you want to double check your observation, what you can do is you can compute f double dash. You can compute f double dash. What will you get? Just compute f double dash. What will you get? You will get 4 plus 1 by x square. Now, if x is coming from 0, infinity, x square is positive, 1 by x square is positive, plus 4 is positive. This means f is throughout concave up. That's a check. That's a guarantee. That's like a double check that yes, my graph is only turning once corresponding to half. That means throughout going to be concave up. And what is the value at half? Is it below x-axis, above x-axis, on x-axis? What? F of half will give you 2 into 1 by 4 minus log of half. This gives you 1 by 2 minus log of 2 to the power minus 1 or plus log 2. This obviously is something positive. This obviously is something very small but something positive. Now we are in a position to draw the graph. See, keep looking on the screen. Keep looking on the screen. Here somewhere, let's say there is half. This is the value which the function is obtaining at half. Something positive. I don't care what it is. Something positive. Something positive. I'll tell you, Naresh. Give me 1 minute. Give me 1 minute. What do you think? As you go to 0, graph is going to infinity. As you go towards 0, graph is going to infinity. And the graph is decreasing before half and the graph is increasing after half. And the graph is increasing after half. This is the value at half. And that's it. And that's it. This is how your curve looks like, f looks like. And when you have to plot f of mod x, do you know what this is? This is f of x whenever x is non-negative and f of minus x whenever x is negative. That means corresponding to non-negative x-axis, you draw the graph of f only, which is this. And on the negative x-axis, you take its mirror image. That means on the left, you will have exact mirror image of this graph. This will be somewhere minus half. Here decrease, here increase. Exact symmetric photocopy. Symmetric images. Because f of minus x is what? Image of f of x about y-axis. That's it. Image of f of x about y-axis. So you can clearly check. If the function says find the interval of monotonicity, you can say from minus infinity to minus half it's decreasing. Minus half to 0 it's increasing. This is decreasing, this is increasing. 0 to half it's decreasing, half to infinity it's again increasing. Minus half and half are the 2 points of minima. And there are no roots of this function because this graph is not touching or cutting the x-axis even once. Alright? Got the point? This is how you draw the graph. This is how you draw the graph, people. Is this clear? Is this clear? Is this question hashtag HDCC, guys? This is very, very important. Supremely important. Supremely important. Clear, eh? Cool. Now there's one more question I want you to do of graphs. E to the power x upon 1 plus x. What do you think? Come on, tell me. First of all, write the domain. Domain is wherever denominator is non-zero. Wherever denominator is 0, you remove that from the set of reals. So the domain of f is nothing but set of all reals minus 1. So leaving minus 1, at minus 1 there will be some asymptote. Chalo, cool. Apart from that, you have to draw the graph everywhere. What will you do? What will you do? Domain is computed. You can see f of 0 is 1. Okay, fine. What about as x tends to infinity? What happens? Tell me. As x tends to infinity, f of x is what? E to the power x upon 1 plus x, right? What happens when x tends to infinity? Can you tell me? This tends to infinity, this tends to infinity. So this is infinity by infinity. So if you compute f dash, you will have e to the power x upon 1 and e to the power x tends to infinity. That means as x tends to infinity, f tends to infinity. What about minus infinity? As x tends to minus infinity, what happens? Can you tell me? Remember e to the power x graph, right? As x tends to minus infinity, e to the power x tends to 0 and this tends to infinity. That means obviously f of x tends to 0. The numerator is tending to 0, denominator is becoming larger and larger, so overall quantity obviously will tend to 0. So as x tends to infinity, function is going up, up, up. As x tends to infinity, function is going up, up, up. But as x tends to minus infinity, function is going closer and closer to 0. But there is some issue. You know what is the issue? When you plot the graph of 1 plus x, plot the graph of 1 plus x, y equal to 1 plus x. So when x is 0, y is 1. Y equal to 1 plus x. When y is 0, x is minus 1. So the graph happens to be something like this. This is a straight line. This is y equal to 1 plus x. Why am I drawing this line? I'll share with you a very minute detail which gets missed quite a lot of times. See, listen to me. As x approaches to minus infinity, Listen to me. As x approaches minus infinity, your graph is also going to minus infinity, but from the, what's happening? As x approaches to minus infinity, your graph is going to minus infinity, not infinity. This is minus infinity. Remember? Yes or no? Yes or no? Look at the graph. When you are approaching to minus infinity, when your input is going to minus infinity, your output is going to minus infinity, not infinity. 1 plus x will go to minus infinity. And what about 1 upon minus infinity? You remember the graph of 1 by x? This is 1 by x. When you approach to minus infinity, your graph approaches to 0 from the left. Can you see this? Your graph is approaching to 0 from the bottom, from the left. Okay, so what are you getting? What are you getting? This is, I will write it properly for you. See, this is e to the power x into 1 upon 1 plus x. As x tends to minus infinity, e to the power x tends to, e to the power x graph is this. As x tends to minus infinity, e to the power x tends to 0 from above, and 1 upon 1 plus x. 1 plus x tends to minus infinity, so 1 upon 1 plus x completely tends to 0 from the left hand side. And hence this completely will give you 0 from the left hand side. Getting my point? That's how much detailing should be there. So when x is approaching to minus infinity, your f is approaching to 0, but from the left hand side, from the bottom side. What about f dash? We have not yet computed f dash. What is f dash? Can you tell me? What is f dash? Come on. Second function, differentiation of first minus first differentiation of second upon second whole square. X is not equal to minus 1. So for any other real value of x, 1 plus x square is certainly positive. Apart from that, you are getting e to the power x 1 plus x minus 1. That means this is just x upon 1 plus x whole square. Now see, now carefully see, look here, x into e to the power x upon 1 plus x whole square. Clearly, this completely is always positive. That means your sign just depends upon x. If x is positive, derivative is positive, x is negative, derivative is negative. So this is positive if x is positive. This is negative if x is negative. And it is 0 when x is 0. That means 0 is the only critical point. 0 is the only critical point, no? Plus, minus, this is the scene. This is the scene. So 0 is the point of minima. Tell me. Clear till here? But now, there is one more thing. The scene is, till now though it's fine, but there is an asymptote at minus 1. So as we approach to minus 1 from the right and from the left, even then I should know what's happening. Because I can't cross this line x equal to minus 1. I can't touch this line x equal to minus 1. I have to approach it. I have to go near to it. That means there is a tending or approaching behavior which is going to happen around the line x equal to minus 1. This is acting like an asymptote. That I have to check first of all. That I have to check. So see what's happening. As x tends to minus 1, f tends to what? As x tends to minus 1 from the right hand side. As x tends to minus 1 from the right hand side, what's happening? See, e to the power x will be some constant. But 1 plus x will go to what? Infinity. As x tends to minus 1 from the right hand side, e to the power x will tend to some constant, but 1 plus x will tend to 0, na? So anything constant upon 0 will tend to plus infinity. Like 1 plus x will tend to 0 as x tends to minus 1, no? And e to the power x will tend to some constant. So this will approach to infinity. And as x tends to minus 1 from the negative, what will happen? Same thing. F will tend to minus infinity. Very good, Naresh. Awesome job done. So now you are almost done. See, At 0, the value of the function is 1. Right? At 0, value of the function is 1 and 0 is a point of minima. 0 is the point of minima and 0 is the only point of minima. Right? That means throughout 0, the curvature will not change. Throughout 0, the curvature will not change. Throughout 0, the curvature will not change. Okay. And before 0, it's decreasing. After 0, it's increasing. Before 0, it's decreasing. After 0, it's increasing. And you also know that as you go closer to -1, the graph is moving to infinity, plus infinity. Yes or no? What will happen here? This will happen here. Why? Because as you are moving closer to -1 from the left, graph is going to minus infinity. No working hard, just a bit of functions is required. Otherwise, I am clearing all the prerequisite needs along the way. Tell me if this is clear. Tell me if this is absolutely clear. Please tell me. This graph is nowhere touching or intersecting or meeting the x-axis. This has no roots at all. No roots. Is this clear, guys? Is this clear? This is decreasing, this is increasing. 1 is the point of minima. As you go to -1 from the left, the graph is going to minus infinity. And as you are approaching to minus infinity, the graph is going to 0, but from the left. Remember I told you, as you approach to minus infinity, graph is going to 0, but from the bottom. From the bottom. That's why such a shape. And yes, x equals -1 is the asymptote, as you can see. Hashtag HDCC, absolutely clear. Wonderful. Wonderful. Now let's move ahead, because I have some questions which really are going to blow your mind away. Look here, this is something which is absolutely commonly asked in the paper. Comparison of two functions can be done by analyzing the monotonic behavior of this. Whenever you are asked that f1 is greater than f2, please bring both the functions on one side and prove f1 minus f2 is positive or f2 minus f1 is negative, whatever. Don't show one function is greater than the other or one function is lesser than the other. Instead, bring both the functions one side and show that their difference or sum, whatever, is positive or negative. Is positive or negative. That is a much better approach to use. Always. Always. For example, in all these 4 options, I have to plot the graph. Each of these 4 options, I will have to plot the graph. Can you help me out with this? After this graph plotting, I'll give you a small break. Can you quickly help me out with this? X is lying in open 0, 1. Which of the following is correct? Now see, this is like F, this is like G. Don't start comparing F with G. Option A I'm talking about. I have to show e to the power x is less than 1 plus x. Is this true or not? What are we going to do? What are we going to do? Instead, what are we going to do? I will take this to the right hand side. I will consider the function 1 plus x minus e to the power x. This is my new function. And I have to show that f of x is positive for all x lying in 0, 1. It's equivalent, no? If I show f of x is positive, that means 1 plus x is greater than e to the power x. Same thing, right? Okay, in 0, 1. Now I know this is clearly continuous and differentiable. 100% continuous and differentiable, for sure. What will I do? I will compute f dash. This will come out to be 1 minus e to the power x. Now you know, as a matter of fact, if x lies between 0 and 1, e to the power x lies from where to where? Remember the graph? This is 0 and this is 1. This is 1 and this is e. So e to the power x lies between 1 and e. When x lies between 0 and 1, e to the power x lies between 1 and e. Yes or no? Yes or no? That means it's greater than 1. It's greater than 1 is what I want to say. When x lies between 0 and 1, e to the power x is greater than 1. If e to the power x is greater than 1, that means minus e to the power x is less than minus 1. So 1 minus e to the power x is less than 0. This is less than 0. If this is less than 0, this implies f is strictly decreasing in your 0, 1 interval. F is strictly decreasing in 0, 1 interval. Got it? Now, why is this important or how is this important? See, at 0, what is the value of F? At 0, what is the value of F? 1 minus 1, which is 0. So, at 0, the value of F is 0. It's not attained, but it's that. And it's strictly decreasing. What about 1? What is the value of F at 1? It is 2 minus E square. Clearly, it's negative. E is something which lies between 2 and 3. No? So, its square will be greater than, much greater than 2. So, 2 minus something greater than 2 will give you negative. So, it's strictly decreasing. This is 1. Right? Got it? This is your F of 1. And it's strictly decreasing. What does this give you? What is the outcome you have obtained? This means F is negative for all x lying in 0, 1 because the entire graph of F in open 0, 1 is lying below the x-axis. So, if F is negative, I had to show F is positive, but F is coming out to be negative. That means A is wrong. A is wrong. Is this cool? A is wrong. Is this cool, guys? Yes? What about B? What about B? Log of 1 plus x less than x. Tell me. Again the same thing, no? Part B. Log of 1 plus x less than x. Now see, you consider f of x to be x minus log of 1 plus x. Okay? Interval is again 0, 1. This is again continuous and differentiable for sure. For sure. We are talking about 0, 1. Now compute f dash. You will get 1 minus 1 upon 1 plus x, which gives you 1 plus x minus 1 upon 1 plus x, which gives you x upon 1 plus x. Now, obviously, if you are in the interval 0, 1, x is positive, 1 plus x will be positive, so this completely is positive. That means f is strictly increasing in 0, 1. Yes or no? Now see, what is f of 0? It is minus log 1, which is 0. And what is f of 1? It is 1 minus log 2. 1 minus log 2 is obviously something positive, right? So when you draw the graph, at 0, the value is 0. At 1, the value is something positive and the graph is strictly increasing. This means what? That f is positive for all x lying in 0, 1. Do you understand? Do you understand? F is positive for all x lying in 0, 1. It's positive. That's what I had to show. If it's positive, x is greater than this, B is correct. B is correct. What about sin x greater than x? This though I have told you. I've told you I don't know how many times. This though you must remember. If I wake you up at night and ask you, you should remember. This is 0, this is sin x, and this straight line is x. You can clearly see when you are very, very close to 0, what happens? When you are very, very close to 0 to the right of 0, what happens? X is greater than sin x. When to the right of 0, x is greater than sin x. To the left of 0, sin x is greater than x. Okay? Okay? When you say x is greater than sin x, that means sin x greater than x is absolutely the wrong option. B is correct, A is wrong. Alright? X is greater than sin x is not greater than x. Cool? Perfect. Now for this, that means I don't need to do so much of hard work of computing the derivative and all. You can do, but I would not suggest that because this much you can clearly visualize and comment. Okay? Just visualize and comment. What about the last part? I know some of you all would be trying. It's okay. Okay, let me do that for you. Suppose we say f of x is sin x minus x. Compute f dash. You get cos x minus 1. Yes, Naresh, working hard. Cos x minus 1, obviously negative. Like cos lies between minus 1 and 1, no? So cos x minus 1 will be negative. Acha, D is wrong. It will be negative. What is f of 0? F of 0 is 0. F of 0 is 0. So your graph is starting with 0. It's strictly decreasing. At 1, obviously the value is something negative. That means your f is negative. F is negative means sin x is less than x. That's exactly the same conclusion you were getting by just observing the graph of sin x and x itself. So you can just use any strategy. All right. What about option D? Anybody? People are saying D is wrong. What about D? Is D wrong or correct? So you consider f of x to be log x minus x. Okay. F dash will turn out to be 1 by x minus 1 or 1 minus x upon x. Now see again the same thing. If x is lying between 0 and 1, minus x will lie between minus 1 and 0. So 1 minus x will lie between 0 and 1. It's positive. So this is positive. This is positive. This completely is positive. But there is a catch. There is a catch. We are in 0, 1 interval. We are in 0, 1 interval and you cannot plug in x as 0. You can't compute f of 0. You can only talk about as x tends to 0 from the right hand side. So as x approaches to 0 from the right hand side, what is happening? Log x tends to minus infinity and x to tends to 0. So minus infinity minus 0 is minus infinity. That means your f tends to minus infinity. And at 1, what's happening? F of 1 is nothing but 0 minus 1, which is minus 1. So that means something like this is the situation. Getting my point? This is the situation. F is strictly increasing because derivative is positive. As you are approaching to 0, graph is going down to minus infinity and at 1, the value is minus 1. So this means f is throughout negative. It's below the x-axis. If f is negative, that means log x is less than x, not greater than x. This is how, it's fine. You can directly also say, that's what I was telling you in this option also. Directly take a look at the graph, visualize the situation and comment, or you can use a derivative test as well. But what is the agenda? What my agenda here is to make you understand that please, whenever you have to compare two functions, take both the functions on one side, treat it as one single function and prove that to be positive or negative, which is a much easier approach. All right, that is something which should be embedded in your head. All right, now this is a result. Very important result, people, very, very important result for x lying in 0, 1, or you can say for x lying in 0, pi by 2. It's okay. You can say this. Please take this as your homework. Take this as your homework. Is the same approach. It's the exact same approach. For this, you have to consider f of x to be sin x minus x cubed by 6 in 0, 1 interval. Same thing, compute f dash, try to check out the values of f at 0, at 1, analyze the behavior and then check what is the scene. Okay? Can you do this? Similarly for cos x. Similarly for cos x, take both the functions on one side and prove this. Will you be able to do this? Or is this a big challenge for you? Will you be able to do this? Yes, definitely comment down below if there is any problem, any issue. I will be more than glad to address the issue. All right. Now we are heading to the last part of our today's one shot. So please sit tight. Understand 3 scenarios under which maxima, minima is majorly used and it comes into play. Because after this, it's almost the end of the chapter. Now, maxima, minima, you already know the basics. You already know the basics. What is point of local max, point of local min, all of that we have used in the questions beforehand itself. But there are 3 scenarios. First scenario, when your function is continuous and differentiable. In this situation, if you have to talk about points of max and min, what do you do? So let's say I give you an example. F of x is x cube minus 4x square plus 7. Okay? Chalo, you take this. So domain, you know, is set of all reals. Domain, you know, is set of all reals. Now tell me this function, because it is continuous and differentiable throughout the real line. It's a very nice, very neat, very clean, very standard polynomial function. How will you compute its point of max, point of min, points of inflection? You should know all of these should lie in the domain. So what will you do? Definitely you will compute f dash. You will get 4x cube minus 12x square. So 4x square comes out common. You are left with x minus 3. When you equate with 0 to get the critical points, you will get what? X equals 0 and x equals 3. When you plot this on the number line, you are going to get plus, minus, and then minus. So it's throughout decreasing and then increasing. So 3 is definitely the point of local minima. And because my function is continuous and differentiable, it's not changing its sign about 0. The derivative is not changing its sign about 0. 0 happens to be the point of inflection. 3 happens to be the point of local minima. But this doesn't mean 0 is the only point of inflection. It might not be. To reach the final conclusion, to get the final set of points of inflection, I have to go to f double dash. So I go to f double dash. What do I get? Okay, so 12x, this is x minus 2. Equate this with 0, you get 0 and 2 also. Now when you plot 0 and 2, you can clearly check f double dash is changing its sign, positive, negative, positive. That means here it's concave up, concave down, concave up. So 0 and 2 are my 2 points of inflection. Both are sitting inside my real numbers domain and hence both are acceptable. Is this clear? So whenever you have a continuous and differentiable function, this is the complete pedagogy that you use to compute the points of max, points of min, points of inflection. The only thing you have to keep in head is points have to always come from the domain. If there is any point which is coming out to be a critical point or a point of max or a point of min, but it doesn't lie in the domain, you have to reject it. You have to reject it consciously. Okay? Can I come to the next part now? Suppose your f is continuous but not differentiable. These are the only 3 parts where you get the questions of maxima and minima. 1, when the function is continuous and differentiable. 2, when the function is continuous but not differentiable. 3, when the function is neither continuous nor differentiable. Okay? If it's not continuous, it won't be differentiable. So you can just say, yes, you are absolutely correct. See. X lies between 1 and 3. Okay. Now for this function, this is a continuous function. First of all, please check, is this continuous? In 0 to 1 interval, it's polynomial continuous. 1 to 3, polynomial continuous. At 1, left hand limit is 1. Right hand limit is again 1. Value of the function is again 1. So definitely f is continuous in 0 to 3 interval. Fine. It's continuous in 0 to 3 interval. But it's not differentiable in 0 to 3 interval. But it's not differentiable. How? Compute f dash. You will realize this is 1 in this interval and this is twice of x minus 2 in this interval. Alright. Now see, in 0 to 1, it's a constant function, differentiable. In 1 to 3, it's a linear polynomial, scalar multiple of a linear polynomial, again differentiable. But at 1, what's happening? F dash of 1 from the negative is 1 and f dash of 1 from the positive is 1 minus 2 is minus 1. This is minus 2. This is unequal. So f is not differentiable at 1. It's not differentiable at 1. It's continuous in the entire interval, but it's not differentiable in the entire interval. In such a situation, what you have to do is please get the algorithm clear. Please get the algorithm straight in your head. What you will do is you will analyze the behavior of the function in each section, in each broken part. Getting my point? Getting my point? This is a broken function. Yes or no? So in each broken part, you will analyze the turning behavior of the function in this part and in this part separately. Then at point where both the graphs are connecting, which is at 1, then you will analyze at the connecting point, which is 1. So 3 tasks you have to do. When you have a broken function like this, you analyze the behavior of the function, the turning behavior, points of max, points of min, inflection points corresponding to each broken part separately. Once both the tasks are done, because there are 2 paths, then you look at the connecting point. The connecting point here is 1. Then at the connecting point, you analyze the behavior, that what is the status there. Is that a point of max? Is it a point of min? Is it an inflection point? What is 1 actually? The connecting point, what is that? So 3 tasks you have to do. 3 tasks you have to do. Is this clear? Is this clear? So let's start. In the first interval 0, 1, what's happening? In the first interval, your f of x is x. It's a straight line. F dash x is 1, which is positive. So f is strictly increasing. F is strictly increasing. There is no turn. There is no turn. That means between 0 and 1, the graph is strictly increasing. It's a straight line, you know. There is no point of max, no point of min, because the graph is not turning only. There is no point of max, no point of min, because it's a straight line. There is no change in curvature also. Bhai, if you compute f double dash, it will be 0, na? If you compute f double dash here, it will be 0. That means there is no change in curvature. It's a straight line. Understood? So we have examined how the function will look like in 0, 1. Now, what about in 1, 3? What is your f of x? X minus 2 whole square, right? This was it, no? Yeah. So f dash is equal to twice of x minus 2. Equate it with 0, you get x equals 2 as one of the critical points, and x equals 2 is lying in this interval, so I can accept it. Now, this is 2. Obviously, plus minus, that means this is the point of minima. That means this is the point of minima, and you already know x minus 2 whole square is a upward opening polynomial whose vertex is at 2. And what is the value of the function at 2? What is this minimum value? Twice of, no, this is 2 minus 2 whole square, which is 0. As I told you, x minus 2 whole square is an upward opening parabola which touches the x-axis at 2. Touches the x-axis at 2. So 2, 0 is a point lying on the parabola. Okay, so this is the status in 1, 3 interval. So when both the broken paths I have analyzed, now at 1, what's happening? What's happening at 1? See, f dash 1 from the negative, f dash 1 from the negative was 1, which is positive, and f dash 1 from the positive was what? Minus 2, which is negative. So of course f is not differentiable at 1. F is not differentiable at 1, but 1 is a successful critical point for f. 1 is a successful critical point for f, people. Critical point, we say, is that point where either the derivative is 0 or undefined. At 1, derivative is undefined, so it is a critical point, and 1 is lying in my set, actual set. 0, 3 is my interval, no? So 1 is lying inside it. No, I can accept it as a critical point, right? After 1, we have negative. Before 1, we have positive. That means the graph will increase, decrease, but at 1, there will be a sharp-edged turn. At 1, there will be a sharp-edged turn. So 1 will be a point of local max, but a sharp maxima. But there will be a sharp maxima. Such an interesting question. Yeah, such an interesting question. So eventually now we are about to draw the graph. This is 0, this is 1, this is 2. Yes or no? In 0, 1, you have a straight line which is y equal to x. Right? At 0, it's 0, at 1, it's 1. Correct. At 0, it's 0, at 1, it's 1. Then 1 pe, there is a sharp edged turn, and the graph goes like this. See, here the functions were very easy. You can very easily draw the graph of x and x minus 2 whole square also. But I'm taking you to the graph by making you understand the actual algorithm that you have to follow whenever the function is continuous but not differentiable. Getting my point? So from 0 to 3. So till 3 we have to just draw. So somewhere here 3 will occur and here the graph will end. Similarly here you can draw, but you only have to draw from 0 to 3. From 0 to 3. So the graph will look something like this. Then immediate turn. Then you go here. It's a parabola. You already know it till here. That's it. So 1 is the point of local max. 2 is the point of local min. 1 is the point of local max, that too sharp maxima, and 2 is the point of local min, but a smooth minima, because at 2 the graph is differentiable, but at 1 the function is not differentiable. Is this clear? Is this clear? Yes? Awesome. Okay, there's one more part. I don't have space. Chalo, I'll explain you here itself. Wait a second. I'll explain you here itself. See, the last part says, the third part, when f is discontinuous. That means it can't be differentiable. No. See, differentiability implies continuity. Not continuous implies not differentiable. So if a function is discontinuous, that means it's also not differentiable. What will you do? So for example, f of x is equal to mod x, and it is 1 when x is 0, when x is non-zero. So whenever your function is discontinuous, like here, see, in general, you know mod x is continuous, but I have made a twist. I have made a little twist. So this is your mod x, this is your mod x, but at 0, the value is not 0, the value is 1. In this case, what you do, people, you go by your actual natural feel. You go by your actual natural feel, or rather you go by the basics, the fundamental. What is the meaning of maxima and minima? The actual inherent meaning. See, what is happening in this case, because the function is discontinuous at 0, you will only analyze the behavior in the neighborhood of 0. You have to check that the left neighborhood of 0, in the left neighborhood of 0 function has to be continuous. In the right neighborhood of 0 function has to be continuous. I am not saying at 0 function has to be continuous. Please check f is continuous in the left neighborhood of 0, which is say minus h comma 0. Okay, this is something, let's say minus 0 minus h, and this is 0 plus h. And f should be continuous in right neighborhood of 0. Once this is checked, next you have to check that f of x, according to the observation of the graph, f of x is, you can see, less than f of 0 for all x lying in the left neighborhood, and f of x is also less than f of 0 for all x lying in the right neighborhood. Is this true? This is the graph, no? For all x lying in the left neighborhood and right neighborhood, for all x lying in the left neighborhood and right neighborhood, whatever are the corresponding values of the function, they are less than 1. That means less than f of 0. So f of 0 is the greatest value in the neighborhood of 0. Even if at 0 function is not continuous, I don't care. I don't care. All I need is in the neighborhood of 0, f of 0 is maximum or not. And that is the case. That is the case. In order to establish that case, the only prerequisite is in the left neighborhood of 0, function has to be continuous. In the right neighborhood of 0, function has to be continuous. There should be no hole, no break, no gap. At 0, even if there is a hole, break, gap, I don't care. But in the left neighborhood, in the right neighborhood, there should be no hole, no break, no gap. So in the left neighborhood, f of 0 should be maximum. in the right neighborhood, f of 0 should be maximum. That's when I say in the neighborhood of 0, f of 0 is maximum. So it is representing point of local max. It is representing point of local max. So at 0, the function is attaining its max. 0 is point of local max. Is this cool? Guys, always keep in mind, whenever you are computing local max, local min, or points of maxima, points of minima, it's not a need for function to be continuous and differentiable. No. In all the three situations I told you, when the function was both continuous differentiable, or continuous but not differentiable, or not continuous, you get points of max, points of min. The approach, how do you reach the points of max, points of min, is different in three cases. That's why I taught you the three cases. But the lesson majorly which I want you to learn is that points of max, points of min don't need a function to be continuous and differentiable. They don't need that. They don't require that. That's not a prerequisite for a function to be continuous and differentiable. Got it? Look what's written here, if you can read. F of A is greater than equal to f of A minus B, less than equal to f of A plus B. That's exactly what I told you. F of 0 was greater than f of x. F of 0 was greater than f of x from both sides. Okay, this is exactly what is written. Basically, what is written behind text that's appearing, I wrote over it, but whatever is appearing is that when your function is discontinuous, what you do is you treat neighborhood. In order to know what's happening at that point where the function is discontinuous, you please check the neighborhood. Whatever is the behavior in the neighborhood, accordingly you conclude that how is the behavior about that point. Got it? Is this clear? I want to share some graphs with you which I feel will blow your mind away and will also clear a lot of things for you. So are you ready? Some little bit of graphs here and there can I share with you, because I would love for you to answer my question. For example, tell me, what do you think is the situation at A? I'm deliberately taking discontinuous functions because I want you to understand how continuity and differentiability is not important for you to conclude maxima, minima, or increasing, decreasing. Tell me. Can you tell me? See, at A function is continuous, but in the left neighborhood of A it is continuous, in the right neighborhood of A it is continuous. This is, let's say, your A minus h, this is, let's say, your A plus h. One thing which you can very easily see is that f of A is greater than f of A minus h and f of A is less than f of A plus h. Yes or no? Yes or no? That means in the immediate neighborhood of A, before A values are smaller, after A values are bigger. That means as you move from the left of A to the right of A, graph is increasing. So you say this implies f is monotonically increasing at A. Did you understand? It's just the feel. Take the feel, guys. Take the feel. Similarly, if I give you another example. Okay. This solid dot is f of A. Now tell me what's the situation. Tell me quickly. Tell me what's the situation. What do you think is the status at A? Again, f is discontinuous at A. So what will you do? You will analyze the behavior about A. This is A minus h, this is A plus h. Correct? This is A minus h, this is A plus h. What will you do next? What will you do next? Anybody? See, in the left neighborhood of A, f is continuous. In the right neighborhood, f is continuous. So, in the neighborhood, left neighborhood and right neighborhood, individual continuity should be established. But at A, it's not important for the function to be continuous. Now, what's happening? See what's happening. Please analyze. F of A is greater than f of A minus h. And f of A is greater than f of A plus h. That means f is very good, Harry Potter. Function is not increasing about a, function is not decreasing about a, function is changing its behavior from increasing to decreasing about a, and that is why a happens to be the point of local max. Is this clear? So be it monotonically increasing or decreasing, be it local max or local min, you don't need compulsorily the graph to be continuous. Is this clear? Yes or no? I want you to tell me quickly, because I am moving on to the questions now and I will not be showing any mercy when it comes to question discussion, because now the actual game starts, guys. Look at this question. Just look at this question. Look at this question and you will realize how good this is and how again it will establish your understanding much more on the maxima minima concept which I explained you. Tell me. Tell me. Are you ready? Are you ready? Let f be a function. It has local maxima at 0. Now the panga here is there is unknown involved. Always remember, because there is unknown involved, I will use my basic definition. Okay? What is my basic definition? In order to conclude that you have a local max at 0, I don't know whether at 0 my function is continuous or not. No. Do I know? No. My right hand limit is coming out to be 0. My left hand limit is not coming out to be 0 right now, because I don't know the value of a. I don't know the value of a. So right now I am not sure, depends on the value of a, I am not 100% sure that my function is continuous at 0. So if I take, for example, that it is discontinuous at 0, then I will use the same approach as just shared with you. That you check whether this is a point of local max or min or increasing, decreasing by examining its immediate neighborhood. Cool? Cool. So what will I do? This is your 0. You will go to the immediate neighborhood. Okay? Okay. Now, if this has a local max at 0, what will you say? You will say two things. If this has a local max at 0, that means f of 0 minus is less than f of 0 and f of 0 plus is also less than f of 0. Immediately to the left of 0, the values are smaller than f of 0. Immediately to the right of 0, in the right neighborhood of 0, the values are less than f of 0. Yes or no? Yes or no? If I talk about this condition, what is f of 0? 0. And what is f of 0 plus? Tell me, no? It is minus 2x square. Look here. Look here. Minus 2x square. Minus 2x square for 0 plus. It will look like this. Please visualize, guys. Without visualization, you will not enjoy at all. For x non-negative, the graph is minus 2x square. So you can clearly see this is a strictly decreasing graph. This is a strictly decreasing graph, no? So if I talk about the right-hand side neighborhood of 0, the moment I go to the right of 0, the value is lesser than f of 0. Yes or no? F of 0 plus is definitely, you can see, less than f of 0. The moment you move a little bit also to the right of 0, look at the graph, it's decreasing, the value is less than f of 0. Yes, so this is so true. This is true. This is true for all x non-negative, right? What about f of 0 minus is less than f of 0? Tell me. F of 0 is to chalo 0. What is f of 0 minus? See, what is this? You can see from a square till 3, this is a constant. And this is a polynomial. 5x cube is a polynomial. So when you say f of 0 minus, is less than f of 0, this is what you have to solve, right? Because I need both the conditions to be true, no? For local max to occur at 0, I need both the conditions to be true. One though I have seen is true for all x non-negative. What about the left one? So f of 0 minus will be a square minus 2a minus 3 plus 5 into 0 cube, which is 0, less than f of 0, which is this. Tell me. This will give me a minus 3 into a plus 1 is less than 0. So you will get minus 1 and 3 plus minus plus. That means a belongs to minus 1 and 3. Oh, you need and. Tell me. Are there any more conditions on A? There is only one condition on A, that it should belong to minus 1 comma 3. But in the option, it's given closed minus 1 comma 3. Can you tell me, Navansh, why closed? I am getting open minus 1 comma 3. I am getting open minus 1 comma 3. If I want closed minus 1 comma 3, I have to allow this quantity to be equal to 0, to be equal to 0, equal to 0, and then I will get closed. But is there a problem when this is equal to 0? No. When this quantity is equal to 0, what is happening? This complete constant is becoming 0. That means you are getting the function's definition for u is then becoming f of x is equal to 5x cube when x is negative and minus 2x square when x is non-negative. In this case, f is turning out to be continuous at 0. It's turning out to be continuous at 0. So what will happen as a situation? What will happen? Minus 2x cube is this and 5x cube is this. So you will get a smooth point of max. You will get a smooth point of local max at 0. Yes, that's why I'm saying it is okay for you to put an equality sign here, because that would just mean that your constant part a square minus 2a minus 3 will be 0. And it is okay for it to be 0, because even in that case, your given hypothesis of the question is being established that 0 a local maxima. You have a local maxima at 0. It's not getting disturbed. No. Whatever is in support of local maxima is at 0. Include that. No. It's not disturbing that fact. If it would have disturbed that fact, I would have not put equal to 0. But I tried putting equal to 0 and it did not disturb that fact. It even established that fact that, okay, it is still continuing to be a local maxima at 0. That to a smooth one I showed you. Because in this case, when the constant is 0, you are going to get a continuous function at 0. And that's why closed interval minus 1 comma 3 is the answer. So please make sure you understand, whenever you have unknowns involved and it's a broken function, please use your basic definition of having a local maxima at a point. बिल्कुल बिल्कुल नवांश, मंडे को without a doubt. Even I wish to do that very soon. All right, look here people, look here. What do you think is the strategy to crack this question? Come on. Quick. Tell me. Tell me. Again, you can see there is an unknown involved. And it's a broken function and it says it has greatest value at 1. So 1 is the point of max. 1 is the point of max. Now the moment 1 is the point of max and unknowns are involved, you know we have to use the basic definition. What is the basic definition? That f of 1 is greater than f of 1 plus and f of 1 is greater than f of 1 minus. Both these situations have to be true. Both these situations have to be true. Is this clear? What about this? F of 1 is greater than f of 1 plus. What is f of 1? F of 1 is 1 minus 1, 0 plus 10 minus 5 is 5. Greater than f of 1 plus. Tell me, f of 1 plus will come from this definition. No. So you will get minus 2 plus log of b square minus 2 to the base 2. So this will give you 7 is greater than log of b square minus 2 to the base 2. Tell me. Yes. So 2 to the power 7 is greater than b square minus 2. Any problem? Yes. So b square minus 130 is actually less than 0. And what is 130? This is nothing but root 130 whole square. So this is b plus root 130 into b minus root 130. This is less than 0. Yes? Okay. So this is minus root 130 plus root 130 plus minus plus. So this implies that your b belongs to minus root 130 comma plus root 130. But there is the catch. Another condition will get attached here, people. Another condition is that b square minus 2 is sitting as the input of log. So b square minus 2 has to be compulsorily positive. So I need b square minus 2 to be positive. Yes or no? That means b minus root 2, b plus root 2 has to be positive. So what will I get? This is minus root 2, this is plus root 2, plus minus plus. So b belongs to minus infinity minus root 2 union root 2 comma infinity. And I need the intersection of both of these. Yes or no? I need the intersection of both of these, no? B is belonging here also and here also, and right now I'm only dealing with the first condition. Understand? I need to deal with the second condition as well right now. That part is left, that hard work is left. Is this cool? Is this cool? That means B will belong where? B will belong, yes, you are correct, minus root 130 comma minus root 2 union root 2 comma root 130. That's from the first case. That's from the first case. Now, next case says f of 1 is greater than f of 1 minus. Oh ho ho. Oh ho ho. For that, I have to examine the graph of this function, Baba. Cha. Because both f of 1 and f of 1 minus are coming from here only. So I should have the graph. I should have the graph. So let me consider the graph x cube minus x square plus 10x minus 5. Just this much part. So f dash will give me 3x square minus 2x plus 10. Yes. What about d? This is a quadratic polynomial. D is b square minus 4ac. 4ac. Clearly negative. And leading coefficient is positive. That means f dash is strictly positive. This is positive for all x less than equal to 1. Because that's my part where I'm using the definition. So if f dash is positive means f is strictly increasing in this interval. So if I talk about the graph of f, I'm talking about less than equal to 1. Less than equal to 1. It's strictly increasing in less than equal to 1. It's strictly increasing in less than equal to 1. It's strictly increasing in less than equal to 1. So at 1, what is the value? 1 minus 1, 0 plus 10 minus 5. At 1, the value is 5. At 1, the value is 5. Okay, and it's strictly increasing before 1. If it is strictly increasing before 1, bachche, then can I say f of 1 is greater than f of 1 minus? I can say this, right? F of 1 is greater than f of 1 minus. Because it's strictly increasing. So just before 1, if you go to the left neighborhood of 1, obviously the value of the function will be lesser than 5, which is the value of the function at 1. So this is true. This is definitely true. And from the first case, we got the range of B. This is the right answer. A. How many of you all are getting A? Perfecto. Did you understand? This is how you actually use your basic definition of having a local maxima at 1, having a local minima at 0, whatever, by using the neighborhood approach, especially when unknowns are involved. Especially when unknowns are involved. Cool? Yes, Kurshid, Ahmad, okay. Everything clear? Everything clear? Tell me, quickly tell me, everything clear till here? Is everything hashtag HTCC? Yes or no? Yes or no? Cool? Chalo. This one I feel you can do for homework because this one you can very easily crack using graph. Draw the graph of f to the left of 0 and draw the graph of 2 sin x to the right of 0. It's that simple. You have to find the point of local max, local min, neither local max nor local min, f of 0 plus is 2 or not. Can you do this? It's very simple, and deliberately I've given you functions which can easily be traced also. So take this as homework. Very simple. I feel you will be able to crack this one. Okay. Come here. That one was simple. Tell me. F of x has where or what as the point of max, what as the point of min? Can you tell me? Can you tell me? Just compute f dash. No, there's no need to brainstorm that much. Just compute f dash. When you compute f dash, you will get 2 plus 3 times 2 by 3 x to the power 2 by 3 minus 1. This will give you minus 1 by 3. This gets cancelled, this gets cancelled. So 2 plus 2 upon x to the power 1 by 3. Yes. What next? What next? Tell me quickly. Quick, quick, quick. You should be quicker than me in computing the answer. 2 plus 3 times, then there is 2 by 3 x to the power 2 by 3 minus 1, which gives you minus 1 by 3. What next? 2 will come out common, x to the power 1 by 3 plus 1 upon x to the power 1 by 3. So you are getting 0 and minus 1. Both are acceptable critical points because the domain is set of all reals. Remember, don't forget the basics ever. Don't forget the basics no matter how much you study any chapter, never forget the basics. We always have to make sure that points that are acceptable are coming from the domain. Both 0 and minus 1 are acceptable. Both 0 and minus 1 are acceptable. So this is minus 1, this is 0. What's happening about 0? Plus, minus, plus. Yes or no? Function is not differentiable at 0, but function is differentiable at minus 1. Is that true? Is that true? Is that true? Function is differentiable at minus 1, so there will be a smooth turn. But at 0, it's not differentiable, so there will be a sharp turn. So this is smooth maxima, this is sharp minima. That's what I wanted to explain from this question. At minus 1, there is a smooth maxima, and at 0, there is a sharp minima. Yes, minus 1 is the point of max. Yes, 0 is the point of min. Nobody in the exam will ask you whether it's sharp maxima or smooth maxima or sharp minima or smooth minima, but you should know. I feel you should know. Okay? Okay, so what is written? X equals 0 is the point of minima. Yes, that too sharp minima, not maxima. F is not differentiable at 0. Yes, it's not differentiable at 0. That is true. It is differentiable at 0. No, that's wrong. Hi, Srinivas. Let's go to the next question, people. Aha. This is a beautiful question. This is an old question. See, here you have a broken function. Here you have a broken function. There are no unknowns involved. And the question is asking you to compute the points of local max and local min. Now, there are two approaches. You can either proceed by graph, by drawing the graph, or I told you what you do is you analyze both parts of the function, the sub parts of the function separately, and then you check at the connecting point. So minus 1 is the connecting point. That we will check towards the end. Is this cool? Is this cool? If you want to first of all use method 1, let's say I use method 1. There are two methods I told you. Method 1, let's say, is the graphical method. Let's keep method 1 as the graphical method. How will you draw the graph? In minus 3 to minus 1, you want the graph. In minus 1 to 2, you want the graph. How will you draw the graph? Tell me. What will you do? See, in minus 3 to minus 1, what's happening? your function is 2 plus x whole cube. Correct? Now you know how this graph looks like, bache. You know it, isn't it? This is x cube. X cube. X plus 2 whole cube means you shift it to the left by 2 units. No. So it will go something like this. No. This is minus 2. Yes or no? Minus 2. This is very simple. This is very simple. It will go something like this. Okay? Got my point? This is minus 2. Now you only need this graph in minus 3 to minus 1. Only in this much part you need the graph. So let me draw the graph here. In minus 3 to minus 1, at minus 2 this is 0. Somewhat like this. Somewhat like this. This is minus 3, this is minus 1 and this is minus 2. Okay? That's it. That's it. And this is at minus 1. At minus 1, what is the value? 1. At minus 1, what is the value? 1. This is how easy it is to draw the graph in minus 3 to minus 1 interval. What about minus 1 to 2 interval? Now, this is where you would need some analysis. See, in minus 1 to 2 interval, your f of x actually looks like x to the power 2 by 3, which means x to the power 1 by 3 whole square. Now, you can remember the graph of this function. I'll tell you what the graph looks like. You can remember it, but right now I want you to please understand how to trace it roughly. See, f dash x, if you find out, you will get 2 by 3 x to the power 2 by 3 minus 1, which gives you minus 1 by 3. So this is 1 upon x to the power 1 by 3. In minus 1 to 2, 0 is there in between. Hi Aryan. Oh yes, of course. I never forget my students. X equals 0 is your critical point. Yes or no? It's a critical point. But your function is not differentiable at 0. Remember, function is not differentiable at 0. Function is in fact, f dash is in fact undefined at 0. Your derivative is undefined at 0. Do you see this? Your derivative is undefined at 0. That means function is not differentiable at 0, but it's a critical point. And what's happening about this critical point? Your graph is changing its shape. It's decreasing, sharp edged turn, increasing. It's continuous, but it's not differentiable. It's continuous, but it's not differentiable. Okay, it's continuous, but it's not differentiable. Decreasing, then increasing. Decreasing, then increasing. So, now listen to me. Now listen to me. What I'm going to do is, at 1, what's the value? It's 1 only. Here also at 1, minus 1, the value is 1. At minus 1, the value is 1. Graph will start from here, go down, sharp edged turn and go up. This is one way to complete the graph. This white graph you can say is of x ki power 2 by 3. But just by drawing this much, you can conclude that minus 1 is the point of local max, 0 is the point of local min. Your answer is obtained. But this graph of x to the power 2 by 3 is not correct. Why is it not correct? Because please compute f double dash. You will get 2 by 3, you have x to the power minus 1 by 3. So minus 1 by 3, x to the power minus 1 by 3 minus 1, which gives you minus 4 by 3. So this gives you minus 2 by 9, 1 upon x to the power 1 by 3 whole to the power 4. You are in minus 1 to 2 interval, denominator is positive. That means throughout this is negative. If this is negative, f double dash is negative. In my interval minus 1 to 2, f double dash is negative, you can see. That means throughout the graph will be concave down. So this will look like a bird, people. This will look like a bird. This is concave down. I'll draw with another color. Concave down, concave down. And here somewhere is 2. Did you understand? This is 2. Again, minus 1 is point of max. 0 is point of min. This is the graphical approach. This is the graphical approach. Of course, minus 1 is the point of maxima. 0 is the point of minima. Is this understood? But this is the graphical approach. In the graphical approach, if there is any graph which is familiar to you, like x plus 2 whole cube is very easy, draw it directly. If something is not familiar to you, please use the plotting of graph approach which I have taught you today to actually get the graph. And this graph, though, you can remember only x ki power 1 by 3 whole square looks like a bird. Looks like a bird which has its vertex at the origin. But if I talk about method 2, this is not graphical. This is not graphical. See, please understand here what I'll teach you, what I taught you, I'm going to apply that. I will be examining both my functions, both my branches, one by one. And then I will be examining my connecting point. Then I will be examining my connecting point. So let's start. First of all, I have in the interval -3 to -1. See, f of x is 2 plus x whole cube. Now, f dash will give you 3 times 2 plus x whole square. Clearly, this is positive. That means f is strictly increasing in this interval. If f is strictly increasing in this interval, that means there is no turn, absolutely no turn. No turn at all, no turn. No turn. There is no turn because there is no increasing to decreasing or decreasing to increasing change in behavior. No, it's not happening. No, it's not happening. There is absolutely no turn. Cool. It's strictly increasing. In -3 to 1, this is strictly increasing. -3 to -1. What about the next part? This is in -1 to 2. Your f of x looks like x to the power 2 by 3. Now see, f dash will be 2 by 3 into 1 upon x to the power 1 by 3. Now this equal to 0 gives me 0 as the critical point, right? Plus, minus. At 0, function is not differentiable. So there will be a sharp turn about 0. So 0 is the point of local minima. So one thing is sure, and 0 is lying in my corresponding interval -1 to 2. So from the first part of the function, I am not getting any point of maximum. From the second part, I am getting 0 as the point of minima. Now I just need to check the connecting point. Yes or no? I just need to check the connecting point, which is at -1. So at -1, I have to check f dash. F dash will give me 3 times 2 plus x whole square. This is -3 less than x less than equal to -1. And this will be 2 by 3 x to the power -1 by 3 -1 less than x less than 2. Now, what is the derivative of f at, like left-hand derivative of f at -1? 2 minus 1 is 1, 1 square 1, this is 3. And f dash of -1 from the right-hand side will give you what? This is negative. This is negative, no? This is -2 by 3. This is negative. That means at -1, function is not differentiable. At -1, function is not differentiable for sure, because this is right-hand derivative and left-hand derivative are not matching. But to the right of -1, I have negative. To the left of -1, I have positive. That means there is sharp maxima. Sharp maxima at -1. Can you see this? Sharp maxima at -1. Brilliant, yeah, brilliant. Sharp maxima at -1, sharp minima at 0. That's it. This is how you analytically conclude points of maximum, and this is how you graphically conclude points of maximum. Is it cool? Am I making sense, everybody? Yes? Yes? This is a homework question. But before I give you this as the homework question, I want you to please take a disclaimer. This is a variety of question which is extremely common to occur in your JEE Main exam. What does it say? Let P of x be a real polynomial of least degree which has a local maxima at 1 and a local minima at 3. If P of 1 is 6, P of 3 is 2, then P dash 0 is what? Please understand, what does it say? It says this has a local maxima at 1 and a local minima at 3. Now, because P is a real polynomial, P of x, bache, is a polynomial. This means it's continuous and differentiable for all x real. There is no x for which my polynomial is not differentiable. So when I compute P dash, I only get my critical points by equating this with 0. That's for sure. I will only get my critical points by equating this with 0. Because there is no point where P dash is not defined. P dash equal to 0 will give me what? One root is x equals 1, another root is x equals 3. These are the two critical points. No, first of all, they have to qualify to be critical points. Now, there is local maxima at 1. and there is local minima at 3. That means this is the scenario. Local maxima at 1, local minima at 3. And that's it. P has only 2 points of extrema, local maxima at 1 and local minima at 3. And these 1 and 3 are critical points. These are the only critical points. That means if they are the only critical points, and critical points can only be obtained by equating P dash with 0, that means these are the only 2 roots of P dash. So P dash has exactly 2 roots. That is 1 and 3. If P dash has exactly 2 roots, P dash is a polynomial having exactly 2 roots, that means it is a quadratic polynomial. And if P dash is quadratic, that means P will be of a degree greater. P is a cubic polynomial. So the least degree for which this can happen is 3. This implies P of x is a cubic polynomial. Am I making sense? Am I making sense, everybody? Please tell me. So when you say P dash, you will write it as lambda times x minus 1 into x minus 3. Open this up. This will give you x square minus 3x minus x minus 4x plus 3. So when you want P of x, what will you do? You will integrate this. You will get P of x is equal to lambda times x cube by 3 minus 4x square by 2 plus 3x plus c. What is this P of x? This P of x polynomial, which I want to find out, because eventually I want P dash 0. So I first need P. I will differentiate it. I will put x as 0. I will get P dash 0. But here understand, there are only 2 unknowns, lambda and c, and it's very easy for you to compute their values. Why? Because you know P of 1 is 6 and P of 3 is 2. You have 2 equations. Plug in x as 1, plug in x as 3. You will get 2 equations in 2 unknowns, lambda and c. Solve them, get lambda, get c. You have P of x with you. Compute the derivative. Plug in x as 0, get P dash 0. This is the correct approach. But what students do, what you must not do is, the moment they decode that P of x is a cubic polynomial, which is a very conceptual decoding, after that what they do is they assume P of x to be ax cube plus bx square plus cx plus d. Now they use the fact that P dash 1 is 0 because 1 is a critical point, P dash 3 is 0 because it's a critical point, P of 1 is given to you as 6, P of 3 is given to you as 2. This gives you 4 equations in 4 unknowns. Why do you want to do so much of hard work? Why? Please don't use this method. Please don't use this method. Use the previous method and play smart. Please play smart, because you are going to really get crisis of time in the paper. So don't do this. Got it? Yes ma'am, no ma'am? Please tell me. All right. Okay. Let's come to this question now. Why is this a good question? Because it involves trigonometry. Now, how exactly do you think you will solve this? How do you think you will solve this? Tell me. How? How do you feel you can find the minimum value of this function? See, f of x is 81 tan square minus 16 sine square. Can I write this as sec square x minus 1? And I can write this as 1 minus cos square x. This will give me 81 sec square x minus 81 minus 16 plus 16 cos square x. So this means 81 sec square plus 16 cos square minus 97. Now sec and cos somehow can help me. Second cos somehow can help me. Why? Because 81 sec square plus 16 cos square. You do realize, bache, that 81 sec square and 16 cos square both are non-negative quantities. And hence what I can do is very good use my AMGM inequality. So 81 sec square plus 16 cos square upon 2 is greater than or equal to root over what? 81 sec square into 16 cos square. So cos square, sec square obviously get cancelled out. Yes or no? So you get 81 sec square plus 16 cos square is greater than or equal to 9 into 4, 36 into 2, 72. So this is at least 72. 72 is its minimum value. So this part is greater than or equal to 72. That means this complete part is greater than or equal to 72 minus 97, which is minus 25. C is the right option. This is how you actually solve such questions. Okay, cool. Now let's take a look at one of the rate measure type of a problem. This is a subjective question which generally gets asked in a paper. The weightage is pretty less. I would not want you to invest too much time in solving these questions, but let's face it, we need to. A wire of length 2 units. There is a wire of length totally 2 units. This is completely 2 units. The length is 2 units. Okay, this is your wire. It's cut into two parts, which are two parts. It's cut into two parts. One is this part and one is this part, which are bent respectively to form a square of side x units. Square of side x units. Now I can make a square of side x units when I have a thread of length 4x, because that is the perimeter. That means this much part is of length 4x and also a circle of radius r units. Now circle of radius r means 2 pi r is the perimeter or the circumference. So 2 pi r has to be the length of the next part. Total length is 2 units. That means what I am getting is 4x plus 2 pi r is equal to 2, right? So that means 2x plus pi r is equal to 1. Or you can say 1 minus pi r upon 2 is what is x. This is the relationship between x and r. Now let's read the question further. If the sum of the areas of square and circle so formed is minimum. If the sum of areas of square and circle. So sum of areas of square is side square and pi r square. This is what I have to minimize. Now for me to be able to minimize this, it has to be a function of a unique variable. It has to be a function of a unique variable, and that means I have to either convert it completely in terms of x or completely in terms of r. Now I have written x in terms of r above, so I will be using that. So s comes out to be 1 minus pi r upon 2 whole square plus pi r square. Writing this, I have converted my s completely in terms of r. So this will give me 1 minus pi r whole square upon 2 square is 4. Now let's compute s dash r, because I have to minimize. Very obvious, guys, very obvious steps these are. 1 by 4, this will give me twice of 1 minus pi r. I am differentiating with respect to r, remember. So twice of 1 minus pi r into minus pi. Okay, that's it. Plus 2 pi r. Pi into 2r basically. Okay, when you equate this with 0, you will get, this gets cancelled 2 into 2. So you are getting what? Minus pi into 1 minus pi r upon 2 plus 2 pi r equal to 0. Navansh, what is the answer? This is the value of r that you are getting when you are equating s dash with 0. That means this is your only critical point. Now, when you plot this 1 upon 4 plus pi, what are you getting? Anything greater than this will give you positive. Anything less than this will give you negative. So this is guaranteed point of minima. If you don't wish to check like this, you can even compute your s double dash. S double dash will come out to be pi by 2 plus 2. Yes, check this out. S double dash will come out to be pi by 2 plus 2, which is positive. which is positive, no? If double dash is positive, in fact, if double dash is positive at r equal to 1 upon 4 plus pi, it's positive, no? If double dash is positive, that means at that point, the graph is concave up. Concave up means this is the point of minima. So 1 upon 4 plus pi is point of minima. 1 upon 4 plus pi is point of minima. Yes or no? Yes or no? Yes or no? Please tell me. Can I say 1 upon 4 plus pi is point of minima? R equal to 1 upon 4 plus pi is point of minima. For this R, I have the sum of areas minimum. But what about x? X was also the unknown. X was 1 minus pi r upon 2. So x was 1 minus pi r upon 2. So this will give me 4 plus pi minus pi whole upon twice of 4 plus pi. This gets cancelled out. You are left with 2 upon 4 plus pi. This is your x. That means your r is 1 upon 4 plus pi. X is 2 upon 4 plus pi. So x is actually 2r. X is actually 2r. See, this is how you have to solve questions which come subjective like this. One is going to be a given condition using which you can express one unknown in terms of the other. And why is that important? Because here you had to minimize surface area. Now surface area, the sum of areas basically. Sum of areas you had to minimize, and that was a function of both x and r. I can't do that. I can't deal with that. I have to make it a function of a single variable so that I can differentiate with respect to that variable. For that, you have to express one in terms of the other, which happened because of this given condition. And then it is a very simple process of applying the first derivative, second derivative test. It's just pretty obvious. Okay, let's come to this question. We are only left with a couple of questions, guys. Just I guess 2-3 questions max, and then we'll wind up the lecture. But these are really, really nice, important questions. Number of real roots of this polynomial is what? These type of questions are asked tremendously in the paper. Number of real roots of this polynomial, x to the power 11 minus 13x plus 5. Now, please understand, what do you have to do here? This is x to the power 11 minus 13x plus 5. One thing, this is an odd degree polynomial. Odd degree polynomial, f dash, if you will find out, you will get 11 times x to the power 10 minus 13. When you equate this with 0, you will get x to the power 10 equal to 13 by 11. Oh my god. That means this is 10, na? That means x will come out to be plus minus 13 by 11 to the power 1 by 10. Oh my god, such pathetic critical points. These are my 2 critical points. Okay, not a problem. This is minus 13 by 11. And this is plus 13 by 11. Plus, minus, plus. This much to chalo is okay. This much to chalo is okay. This is max, this is min. Cool. But I still don't know how many real roots are there. I will be able to know that when I have the perfect graph of this function. When I have the perfect graph of this function. For that, please understand, because this is an odd degree polynomial, as x tends to minus infinity, f tends to minus infinity. As x tends to infinity, f tends to infinity. So as x tends to infinity, this will go infinitely up. As x tends to minus infinity, this will go infinitely down. But again, guys, again, there is a problem. There is a problem. This is, let's say, minus of 13 by 11 to the power 1 by 10. And this is, let's say, 13 by 11 to the power 1 by 10. Bad quantities. Until and unless I know the value of the function at these quantities, I can't draw the graph. It might happen the graph looks like this. This is the point of max, this is the point of min. Or it can happen the graph looks like this. Right? Or it can happen the graph looks like this. So all of this, whatever is the trace of the graph, which will give me how many times the graph cuts the x-axis, I will be able to determine that when I have the values of the function at these inputs. And that is what makes this question tricky. Because computing the values of the function at these inputs is a real task. At 0, what is the value? 5. Okay, at 0, the value is 5. Cool. But at these pathetic inputs, I don't know the value. And I don't want to compute the value. What will I do? Tell me. See, 13 by 11 is greater than 1. So 13 by 11 to the power 1 by 10 is greater than 1 to the power 1 by 10, which is 1. This is greater than 1. Right? So 1 will fall somewhere here. Minus 1 will fall somewhere here. Okay. And at 1 and minus 1, I can compute. At 1, I am getting 1 minus 13 plus 5. Minus 7. And at minus 1, my value is minus 1 plus 13 plus 5, which is 17. 17 is way too much. So at minus 1, I'm getting 17. So understand how I will draw. As you approach minus infinity, the graph is going infinitely down. As you approach plus infinity, the graph is going infinitely up. At alpha, there is maxima. At beta, there is minima. Now see. See how I'm drawing. Good till here? At minus 1, let's say the value is 17, then at alpha it will be bigger than 17. No, because alpha pe there is maxima. I don't know what is the value at alpha, but at minus 1 it's 17. So at alpha it will be something greater than 17 for sure. Right? And at 1 it is minus 7. So at beta it will be something even lower than that. At 1 it's minus 7. At beta there will be something lower than that. This is minus 7. And then it will go up. Yes or no? So yes, it's true. It has 3 real roots. Bang on correct, Navansh. Very good. Awesome job done. But please understand, the major idea behind sharing this question with you was, do not sit and compute the values of f at these irritating, non-good looking points. Please play smart, like we did here. At 1 and minus when we computed the values, which was very simple, we knew the remaining behavior of the graph, and that gave us the shape of the graph. Rough shape, still this is not the exact shape, but rough shape. Rough shape is what we are majorly concerned with. Okay? All right? Now, this is your homework question. I want you to please take this as a homework question. Why? Because this will clear to you the idea of global max and global min. Here, what you have to do is you will compute the derivative. Please listen to me carefully. Please listen to me carefully. You will compute the derivative. Using the derivative approach, get the critical points, get the points of local max, local min. But you will also find out the value of f at the end points minus pi by 2 and pi by 2. And then compare at which value you are getting the maximum answer, minimum answer. Whenever we talk about global max and global min, we always compute the values at the end points of the interval if they are included. If suppose I was given that compute the maximum value of f in open interval, then I wouldn't have been concerned with computing the value at the endpoints, because endpoints are not a part of the interval. But when I am talking about closed interval, that is where global max, global min comes into action. If it's an open interval, no need to check at endpoints. If it's a closed interval and you are interested about maxima and minima, do check at the endpoints as well. Do check at the endpoints as well. The critical points, local max min points, and the endpoints, and eventually find out, comparing everything, what is the highest, what is the lowest. Will you do this? This is very simple. Will you do this? Oh yeah, cool, cool, cool. This is green color, no? That's why it's not visible. I think right now just zoom and solve the question, but thank you for letting me know. Thank you for letting me know. Okay? Chalo. Let's take a look at this question. What do you think? This is again a very famous variety, a very, very famous variety. I want all of you all to please take a look. F of x is given to you as x to the power 5 minus 5x plus a. Correct? Now, f has 3 real roots if a is greater than 4. Only one real root if a is greater than 4. 3 real roots if a is less than minus 4. 3 real roots if a is lying between minus 4 and 4. What do you think is the right answer? Good evening. Yes, 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 yes. This is a PYQ. Can you tell me? It's a very nice question. Very nice. f of x is x to the power 5 minus 5x plus a. Remember, domain is set of all reals. No need to get confused. Now, f dash x will give you 5x to the power 4 minus 5. This means 5 common, x to the power 4 minus 1 is 0. So, x to the power 4 is 1. That means x actually is coming out to be plus minus 1. These are your potential critical points. Minus 1 and plus 1. Yes or no? Plus, minus, plus. Okay? Smooth maxima, smooth minima. Perfecto. Smooth maxima, smooth minima. But if I want to draw the graph, I also have to check, because it's a odd degree polynomial, as x tends to infinity, f tends to infinity. As x tends to minus infinity, f tends to minus infinity. Now see, now the actual game starts. Now the actual game starts. Okay. At 0, the value is a. Fine. Tell me. I used to get confused in this one. When I differentiate, a factor disappears. Which factor? Which factor? See, when you, okay, if you want me to solve this further, see, this is like x square whole square minus 1 square is 0. So, a square minus b square is a square minus b, in a square minus b square is a plus b into a minus b. Now, x square plus 1 is always positive. It's always positive, right? X square plus 1 is positive, no? So, it can't be equal to 0. That means x square minus 1 has to be 0. So, x square will be 1, x will be plus minus 1. This is how you get it. Okay. Okay. Now, see this. This is minus 1 and this is plus 1. If you want 3 real roots, at minus 1 there is maxima, at 1 there is minima. At 0 the answer is a. I don't know what a is, but whatever. If you want 3 real roots, it can only happen when the graph behaves something like this. Yes or no? 3 real roots, justifying the fact that as x approaches minus infinity, graph goes down. As x approaches plus infinity, graph goes up. At minus 1 there is maxima, at 1 there is minima. Justifying all of this, if you want 3 real roots, this is the only way. This is the only way. Yes. What is the meaning of this way? This means f of minus 1 has to be positive and f of 1 has to be negative. There is no other option. F of minus 1 means minus 1 plus 5 plus a has to be positive. So, 4 plus a has to be positive. A has to be greater than minus 4. And f of 1 has to be negative. That means 1 minus 5 plus a has to be negative. A minus 4 has to be negative. A has to be less than 4. So, a has to be less than 4. A has to be greater than minus 4. 3 real roots when a is less than 4 and greater than minus 4. D is correct. D is correct. This is wrong. This is wrong. Only one real root? What about only one real root? Tell me. Only one real root. Keeping everything else intact. Okay, remember. Minus 1 pe, there is maxima. 1 pe, there is minima. You want only one real root. That means something like this can happen. Or with some other color, if I draw, something like this can happen. So, this means f of minus 1 has to be positive, and f of 1 has to be positive. And what does the yellow graph mean? In which case, again, there is one real root. This means f of minus 1 has to be negative and f of 1 also has to be negative. Either this or this will ensure there is exactly one real root. In both the cases, you can see this means f of minus 1 into f of 1 has to be positive. F of minus 1 into f of 1 has to be. This is the combined condition. Obviously, so f of minus 1 into f of 1. F of minus 1 into f of 1 means what? Minus 1 plus 5 plus a into 1 minus 5 plus a. This has to be positive. So, 4 plus a into a minus 4 is positive. A plus 4 into a minus 4. right? A plus 4 into A minus 4. So this gives you minus 4, 4 plus minus plus. So A less than minus 4 or greater than 4. Cool. That means B is correct because it says greater than 4. So B and D are correct. A and C are incorrect. Yes. Is this clear? Could you visualize what's going on? Because if you are not able to visualize, you will not be able to really appreciate. If you are not able to visualize, you will not be able to appreciate. Okay? This one I have already solved with you, already done. Remember the biquadratic polynomial which I changed for you deliberately was this one only. So I've solved this one beforehand. Alright? Alright? Now, let's come to this question. This is the second last question of today's session. Let's come to this question. Shortest distance between this line and this curve. What do you think is the answer? What do you think is the answer? And what do you think is the logic? When you say shortest distance between two curves, this is always along the common normal. Always along the common normal. Very good, UD. Always along the common normal. Always. Always. This means if there is a line and a curve, when you say x square equals 2y, that means it's an upward opening parabola. X square equals 2y, vertex at origin. And when you say x minus y equal to 1, when y is 0, x is 1. When y is 0, x is 1. When x is 0, y is minus 1. When y is 0, x is 1. When x is 0, y is minus 1. Line is something like this. This is y, or rather, yes, y equal to x minus 1. The slope of the line is actually 1. And what is the curve? The curve is x square equals 2y. Now, please understand, if you wish to find out the shortest distance between these two curves, it will be occurring along the common normal. It will be occurring along the, let's say, common normal. Let's say this is your common normal. When you say common normal, what does this mean? This simply means that when you draw tangent to the curve at this point, let me rub this and draw it perfectly for you. When you draw tangent to this curve, what will happen as a result is, this is y equal to x minus 1. When you draw tangent to the curve at this point, the tangent line will be parallel to this line. See, whenever you have two curves, this is one curve, this is one curve. You wish to compute the shortest distance will be along the common normal. This line is the common normal, means at this point you draw the tangent, at this point you draw the tangent, both the tangents are parallel to each other. And hence, from here to here, whatever distance is there, that happens to be the shortest distance. You understand? Both the curves, you want to compute the shortest distance between them, draw a common normal. That means wherever the normal is touching the curve, there if you draw the tangent, tangents will come out to be parallel. The distance between these two parallel tangents is what is the shortest distance. That's the concept. This is the concept. But here, one is a curve and one is a line. So this line itself is acting as a tangent. No. So I need to compute this distance. Let's say this point is A, let's say this point is B. AB is what I need to compute. So what will I do? This is the general approach. See, x square equals 2y is the curve. Differentiate. You will get 2x equal to 2y y dash. So y dash will come out to be x upon y. Now y dash at point A, let's say point A is x1, y1. Understand? Point A is x1, y1. So dy by dx at point A will give you x1 upon y1. Two y dash, not y. This is 2y dash. So 2 cancels. Y dash is equal to x. Right? So at point A, this will be x1. At point A, this will be x1. At point A, this will be x1. What is dy by dx at point A? This is the slope of the curve. Slope of the curve at point A. slope of the tangent to the curve at point A. X1 is the slope of the tangent to the curve at point A. So this is your tangent and this is your L line, which is again a tangent only of the line. The tangent to the line is the line itself. So tangent to the curve is parallel to the line. So both their slopes will be same. No. So x1 is the slope of tangent to the parabola. And what is the slope of the line? 1. Right? It's 1. So x1 has come out to be 1. Now x1, y1 belongs to the curve which is x square equals 2y. And x1 is 1. So plug in the value 1 comma y1. Right? Plug in the value 1 equals to 2y1. So y1 will come out to be 1 by 2. That means your point A has come out to be 1 comma 1 by 2. And from point A till point B, you have to find the distance. So this is very simple. A is 1 comma half. And the line is what? Line is x minus y equal to 1, right? X minus y minus 1 is 0. So what is the distance? This is my answer. It will be 1 minus half minus 1 upon root over 1 square plus 1 square. Mod of this. So 1 minus 1, 0. This is 1 by 2 root 2. Are you getting this? Acha, in that case, Yudi, what do you do? This is one curve, this is another curve. Right? What do you do? I'll tell you. This is curve 1, this is curve. Listen to me carefully. Let's say this is the common normal. This is one tangent, this is another tangent. This is T1 and this is T2. Listen to me carefully. What do you do? What do you do? You differentiate the first curve. This is your point A, right? You differentiate the first curve. Take this as x1, y1. Listen to me very carefully. You differentiate the first curve and at the point x1, y1, you compute its slope. So you have the slope of tangent 1, right? You have the slope of tangent 1. You have the slope of tangent 2 similarly. You have the slope of tangent 2 similarly and both of them will be equal because the tangents are parallel. Yes. When you do this, you will be able to get the coordinates of a point and from that point again, you will compute the distance to the line. The distance of a point from a line, distance of a point from a line. This again and again will get used and you will get the answer of AB distance. I will just give you an example. Just wait. To make you understand, just give you an example. But is this question understood? Is this question understood, people? 1 by 2 root 2. Is this question completely understood? Yes, ma'am. No, ma'am. It's a PYQ. It's a very nice question. Is it understood? Yes or no? Quick, quick, quick. Tell me. Yes? Yes? All right. Now please look at this question. Let the tangent to the curve at point P on it. Now this is very, very simple question. Very simple question based upon tangent and normal. I hope you know this. Do you know the concept of tangent and normal? This is the curve. Let's say this is the tangent line at point P, x1, y1. This is y equal to f of x. I hope you know this. What do? You compute f dash x, which is dy by dx. At point P, this gives you the slope of the tangent. And once you have the slope of the tangent, point slope form will give you the equation of the tangent line. Point slope form will very easily give you the equation of the tangent line. Now, if you draw the normal as well, then slope of tangent into slope of normal is -1. Negative reciprocal of each other, right? You have the slope of tangent, its negative reciprocal will give you slope of normal. Point and slope will again give you the equation of the normal. That's it. This is the only concept. So what does the question say? Tangent to the curve at point P. Listen to me carefully. Tangent to the curve at point P. Tangent to the curve at point P. Listen to me. The curve is x square plus 2x minus 4y plus 9. Tangent to this curve at point P. Let's say this is the curve. This is the tangent to the curve at point P, which is 1, 3. So you know what you have to do? Differentiate and compute the value at P. This will be 2x plus 2 minus 4y dash. Tell me quickly. Yes or no? This is the curve, no? It's the curve. Carefully observe, this is the curve. What is the curve? I'll write again for you. See, this curve I am talking about. Acha, this is given, this is equal to 0. Okay. So, x square plus 2x plus 9 equal to 4y. Write it like this, or upon 4 equal to y. This is a neater way of writing. Cool. So, 1 by 4 as it is, 2x plus 2 equal to y dash. Now, compute the value of y dash at point P. So, slope of tangent will come out to be 1 by 4, 2 plus 2. This is equal to 1. Acha, chalo. Slope of tangent is 1. Slope of tangent is 1. Chalo, cool. Okay. This tangent meets the y-axis at A. Acha. Can I write the equation of the tangent? Yes. Y minus y1 is slope times x minus x1. So, y minus 3 equal to x minus 1. This means y equal to x plus 2. This is the tangent. It meets the y-axis at A. So, y-axis means x equal to 0. Y-axis means x equal to 0. Intersect. You will get y equal to 2. This implies point A is nothing but 0, 2. Acha, acha. Let the line passing through P parallel to this line meet the parabola at B. Chalo, A to we have got. Let the line passing through P. Acha, there is a line L passing through P which is 1, 3 parallel to line x minus 3y equal to 6. This means you can write this as 3y equal to x minus 6 or y equal to x upon 3 minus 6 upon 3 is 2. When two lines are bache parallel, their slopes are same. So, slope of line L will also be 1 by 3. Baba, slope of this line is 1 by 3, y equal to mx plus c. So, slope of line L will also be 1 by 3. Right? So, the equation of this line will give you y minus y1 is slope times x minus x1. Okay. Let a line passing through be parallel to this meet the parabola at B. Now, this line intersected with parabola y square equals 4x will give you B. So, you don't have to do anything. What is this? This is just y minus 3 equals x minus 1 upon 3. So, from here you can compute the value of y, plug it here, get x. Am I making sense? Is this making sense to you? Huh? This is what? 3y equals x plus 8. Let me write it directly for you. 3y equals x plus 8. So, when you intersect, what will you get? When you intersect, you will get y square means x plus 8 upon 3 whole square equal to 4x. This you have to solve for x. This you have to solve for x. You will get x equals 4 and x equals 16. But which one will you accept? Which one will you accept? Remember this line L, this line L is actually meeting the parabola at B. So, this is a parabola, and the line, let's say is this, meeting the parabola at B. So, B is a point which is lying on the line and on the parabola. Tell me. Yes or no? Yes or no? It's lying on the line and on the parabola. So, which one do you think you will accept? Because see, if your x is coming out to be 4, plug in x as 4, 8, 9, 10, 11, 12, y will also Am I audible? Am I audible, Naresh? We're just done with the session. Am I audible? Yes. These are your homework questions, guys. Please take a note. This is question 1. This is question 2. This is question 3, extremely important. Question 4 and bingo. And bingo. That's it. These are your homework questions. 1 or 2 homework questions I've given you along the session as well. Please make sure you attempt all the questions. Please make sure you attempt all the questions and let me know in the comment section below the answers of it. If you understood the entire lecture,